Hello my friend, you want to create a game, I know this, and to be honest you would like to probably only download the tool and start doing it. I know, I just want to say one thing. This is the best time that we've ever had to create games. It's never been such easy task because engines like, for example, Godot makes so much work for you, okay? You don't need to know the basics of physics, don't need to know how to create animations as much as it used to be. There's so much free resources that you can just download and use in your game even for free and sell it. And well, Godot is free, it's open source, and well, you can develop your game on any platform, really, any platform in this software and publish it and sell it, right? So it's not only best time to, learn it because of the fact that it's easy, and well, we've got AI that's gonna help you in this process also, not only me. That's also easy because all the interface and all the work that's been done by, people who were creating games is like in this engine because it's also open source, right? So everybody can contribute to make this engine each day better. Highly recommended. I would like to also tell you, well, maybe what is this engine, right? Well, imagine a car without engine. You can't drive a car without engine. You can start the journey. It's the same for creating games. If you want to create a game, you want engine, so something that has tools that's gonna help you. So, for example, the animations, as I said, the physics. So when something collides with something, you do not need to, know physics. You just need to know how to interact with the elements in this engine, right? And this is very cool. Let's see what games were created in this engine. Potato, Dawn Keeper, Halls of Torment, and for example Backpack Battles. Mainly the popular ones are created in 2D. It's because mainly this engine is used by indie games, but really the result of this game, like for example here, as you can see, how many players are playing it currently, but how many players left the user review, check the AAA titles, okay, and compare this number, okay, how many user reviews were there. And really, for example, in Diablo 4 on Steam, there were like 30,000 people online in the same time. And well, this game has been on the market for a very long time and it has 4,000 currently. I'm showing these games because these games, well, they do not look like, something hard to make. Well, there had to be lots of, love put into this game to make them so popular, even if they do not have a graphics like that, right? But you need to understand that you are able to do the same thing now. Put the work into it in this course, learn how to make a game very fast without having to have a knowledge regarding programming, and see for yourself if that's the thing that you want to do. Because yes, after this course you're gonna create your first working game, which is gonna be a simple one, right? But you're gonna gain lots of knowledge about not only creating a game, but also about yourself, how you feel while doing it, and afterwards you can improve yourself. It's not like I know everything about Godot right now. No. Creating games in Godot or any other engine, and well, creating games is a never-ending story, and this is really great because this is something that makes you want to live. It makes every day beautiful. You can learn something new and be better at it, and you can show the result of your hard work to people, and maybe even someday be very successful on, for example, Steam. In order to download Godot, you need to go to godotengine.org and click on the download latest version, and then click here and you can make a donation. It's not needed, but hell, you can support them if you want, and you need to just wait a second for downloading it. Notice that the version is like this. Do not worry if it's higher, because we are learning the fundamentals of Godot, not the newest features, because well, newest features are mainly coming as for the newest version for people who are a bit more advanced. And no, we are not going through most advanced topics in this course. We want basics, the fundamentals that will set you up for creating whatever you want in future, because then you're gonna expand your knowledge, right? So let's open the folder, and now we've got here the file like this. We need to hold the right button, extract it, and after extracting the zip, we can open our Godot. And really, this file here is now your Godot app, okay? You can change this name, and this is not gonna install on your computer now, okay? This is the app. You open your Godot engine from here, so it's good idea to put it, for example, on desktop, okay? And now when you open it, you can create your first project. So how do you create a project in Godot? In order to do it, you click New. Afterwards, you put here the name of your game. So name of your game, right? And afterwards, you need to choose the path for your game. So where it's gonna be stored, on which disk. So for example, let's say it's gonna be stored on disk, for example, C, right? And we gonna choose this folder, create a folder with the name of my project, and afterward we're gonna choose the rendering process, which is gonna be Forward Plus. What's the difference between others? Doesn't matter for you now. Let's just create and edit. It's gonna be important for you later, in future, when you're gonna export it, not now when you're starting your journey. What do we need to create a game? Well, we need some images, sounds, well, visuals, textures that will represent our game. And normally you would need to start from learning all the skills that are needed to do that, because otherwise you wouldn't be able to put here anything, right? But fortunately for us, there are now lots of websites that offers free, look here, price, free resources, like for example, this one, wow, and it can look good, as you can see. This is just awesome looking 2D graphics, and it is under the CC0 license, which means you don't even need to mention these people, and you can distribute, remix, adapt, build up on the material in any medium or format, even for commercial purposes. You can click and read the license here for more info. So this is the best license. You don't need to even mention them, right? However, of course, I think that it would be good thing to mention somebody who made such a good work if you had made a game within a word like this, right? And you can start creating right now, because, well, you go here, you choose, oh, I want some music. Let's see what's here in the free section. I need some fonts for my, okay, I need the user interface, okay, so I download something from here, and I need some sprites, so some visuals, images, okay. The sprite is just different name for visuals in your game. And wow, so many options here, right? Choose something from here and just start your journey without having to worry. And you need to only hit here download. You don't need to pay them anything, but I think it's a good idea to pay if you're gonna use it in your game later and have some money from it. So people like that will create more content. As you can see, they created lots of more content here for free. Awesome. And after downloading it, all you need to do is what? Extract. Wait a second, 500 elements. Imagine how much work you would need to do such thing, right? And how do we use it now in our project? And this is the first thing you're gonna learn now in this course regarding the engine. We've got here file system, and this is the place where we put any files that are connected to this project, right? So we want this folder to be moved here. And when I put it here, as you can see, it's in our file system of the project game that we are working on. And what now? Well, now we need to, open the folder, and we can use all the things from here, right, in the game. But before we do that, we're gonna need to learn a few more things. However, let's focus on this thing, file system. In order to create a new folder here, because you need to start organizing since the start things here, because, as you can see, lots of things can be connected to your game. Not only, the assets, but also, for example, in future, something what is called scenes and scripts. You could get lost in this. So you're gonna need to know how to create new folders. So right click, create new folder, and we're gonna create here something what is called assets. And this is the folder where we're gonna put things that we're gonna use in our game from this folder, okay? So we want to use something like factions, knights, troops, warrior, and here we can choose the color of our warrior. So for example, let's say I want the red one, and I'm gonna move this here into assets, okay? This is the asset, and when I open it, as you can see, lots of animations are here that we can put in our game, that we can use. Very cool, right? We can sort it even further, but we'll do it later. But for now, I would like to give you an exercise. Everything that I do in each lecture, including this one, you must do instantly or after the lecture. Why? Because even though all the things that I did here seems simple, right? Because, hey, I just needed to do what? Oh, okay, so I needed to just find something here and download it and just open, extract things and put it here. That's like nothing. But believe me that there will be lots of things that we're gonna do inside the game engine. And if you finish this course without doing what I do, you're gonna open the game engine and you will have an empty head. Because our mind, because of how many we've got videos nowadays on YouTube, on TikTok and other social media, works like that. Okay, I just watched it, I do a school, I've got a dopamine hit and well, let's forget it because there is just so much information. But if you decide now to, okay, it's time to stop. I need to, reinforce my manual thinking like, hey, I need to click here, then here, okay? That it's gonna stick in your mind that, hey, it's important. He did a bit more than normally, right? He didn't just watch this. So you have to watch what I say, but also implement it, which means do it. You learn by doing, not by watching. No. That's not enough. You learn by doing and also noting. So whatever you've just learned, like for example, hey, what are assets? Okay, so these were images, sounds, and visuals. File system, okay, note it down. File system is a place in our Godot engine where I'm gonna put my files. What else did I learn? I think I said something about sprites, not sure. Okay, so here is sprite. So this is the different word for what? Generally 2D images used in games to represent objects, right? Okay, so that's it. And you should write it down on your own. Try to think like what words would you use to describe these things, right? So practice, because of practice you're gonna become a game developer. Watchers do not become developers. Practice. And if you have any questions, feel free to ask. How to run your first game, and also I will introduce you the most important basic definitions that are needed to know what's going on in this game engine. In order to run your game, you need to click on this play button here. And the problem that we've got here is that we do not have the main scene. It hasn't been, defined, it says. Well, let's select that. There is no scene here also. We need to create it. But what is scene? Scene, as the name suggests, is when you go to the scene, when you're listening to some kind of concert, you're gonna see there people who are playing music on guitar. So they are doing some cool things there, right? They are making action. And yes, the scene is like the action that we want to present to the user, to the player, right? And as you can see, we have here some kind of 3D scene, but we're gonna focus on 2D because, well, 3D is just a bit harder to learn, so it's better to learn first is something that is easier. So we're gonna focus on 2D, but remember, if you learn something here, it's gonna be also useful here. So let's start from this, and we've got here an empty space, and we now need to define what kind of scene we have got here. As you can see, we've got here the tab that is called scene, and it says you should create now the root node. And you need to decide if it's gonna be the 2D scene, 3D scene, or is it user interface for people. So, because we are focusing on 2D, we're gonna choose this. And well, why is it called root? Because if you think about a tree, right? Root is like something that you start, doing all the things, right? If you want to grow the tree, you need to start from scratch, so from the root. And this is the main scene which we're gonna hit here. And now we've got here unsaved progress, the asterisk is here, and we need to save that thing that we did here. Well, we didn't do much other than just adding something like this. So we're just gonna save it using the Ctrl+S, and we need to now name the thing that we've just created. Let's create a new folder and let's call it scenes, okay? Because we want to organize everything, and here we need to put the name for our scene, and we're gonna call it game, our game, right? So you can call it game, or you can call it level, because we're gonna design the level of our game, for example, the dungeon or whatever, right? You are designing something here, so call what kind of scene, what kind of concert you're gonna design here, right? And I'm going to click save, and we've got empty space that we can now select and run. So we've just run our first emptiness game. Empty game. And let's put something here. Let's put an icon. So in order to put something, as you can see, I'm duplicating all these things when I'm moving from here. Here I've got what, 3 icons, right? They added to this main root thing that was added to the scene. And when I hit the play, we've got 3 icons here presented. So hey, it's working fine. And the question is why this thing here is called node, as you can see. It's because, well, node can be expanded, right? Node is really something that you tie, right? You can tie or untie it, right? So that's why it's called node, and you can put many things together into node. You can categorize things, and node, which doesn't have additional name around it, is like the most universal type of node. There are many types of nodes in this game engine. So this is like something that is used mainly for holding things, for grouping things, right? You're gonna get this, naming convention a bit better when we're gonna, put much more things into this game, okay? But this is like the main thing for grouping right now. So we're gonna call this game, and later what we can create here more things, not an icon. We can put here sound, and we're gonna put it into our game, the scene that represents our game. We're gonna put here, for example, I know, user interface. We're gonna put here player, and we're gonna just attach all these things to this main node that we can expand, or we can just untie it, right? So to be honest, this is for the sake of grouping things. This is like the main node, but you can create many more nodes later here inside, and you're gonna see it on practical examples in future, right? So you can have, for example, the coin, which has got, for example, image and so on, and you can reuse it and so on. You're gonna learn things like that. In this lecture, I just want you to remember that we need a main scene where we start our game. We can now play it, right? And to this scene, we can attach a main root node, right? So something that we can tie and untie. And to this, we can attach much more content that is connected to this game, to this scene. And we can now just run it, play it. Very cool. The question is, how do we put here things that gonna, interact with each other, and we're gonna learn things like that in future. Let's add player into our game. Yes, let's start from something interesting, not so from something what is boring. So in order to do it, we need to expand our game. In order to expand it, we're gonna expand it with new nodes. The same happens to trees, right? You've got a root. That's why it's called the root node, right? And you attach to this root, when it grows to the tree, what? Many nodes, which are the branches, right, of the tree. So this is like one branch, second branch, third branch, right? And we want to add here a player to this particular game. And in order to do it, we're gonna add a branch, which is a node. This is just another name. Node, branch. And in order to do it, we're gonna hit the plus button, or we're gonna hit the Ctrl+A shortcut. And here we can search for things that we can add to our game. When you search for 2D, you're gonna filter out the things that you are not interested in, so from 3D things, for example. And now all the things that you can see here, you do not need to memorize. You're gonna get used to them when you start using them. And in our case, we need some kind of body. We've got what? This body, this. And to be honest, all of them are very useful for particular reasons, because they have some kind of specifics, some kind of things that were written by Godot engine creators that will help you achieve what you want. And in case if you want the physics body that is specialized for characters moved by script, so hey, this is probably for player, right? You have got here moving player as an icon. Then we're gonna choose this one. When you should choose others, well, you're gonna need it, and I will show you it only if we need it, okay? Because this is stupid to start memorizing like in some courses. So I need this when this when this. But hey, you haven't even seen one particular example. How do you even know when you should choose what? So this is a node that we're gonna create, and this thing is specialized in movement. And as you can see, we have got our character body here that is not visible, so we don't have it. When we run our program, we have got only icons here, right? And we don't have our character, but hey, there is body, there should be body here. Well, but we are the people who should define what kind of body this character have. And this is now very important. We need to add an image of our character. Notice that all these icons here are some kind of image, right? So we could probably choose this as our character, for example, but we're gonna use the assets that we've downloaded before, right? The thing that I want you to notice is that when you choose any of the node, here we have got something like inspector, and this thing inspects, it says, controls what really is the node about. So the thing that we have just chosen, right? What kind of branch is that? What kind of the component we've got here, right? And here, as you can see, it says Sprite 2D. Sprite is just another name for visual elements, okay? So this kind of node stores what? Visual elements, but the one that are not animated. We want animated sprite. So when we choose our character body, we want to attach to this particular character, okay, to this guy, not to our game, but to this guy, another child node, so something that is like below this character body, and we're gonna use here something what is called sprite. By this time, it's gonna be animated. And now when we create it, this is gonna be like attached to this, okay? Because we want to connect this to this. We don't want to have it separated, right? This is, very similar like a folder, right? Okay, so this is a player that has got what? Image like this, is gonna have sound like this, blah, 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 blah. So we're gonna attach all the things that are connected to this node with particular node of player here, right? Anything that is connected to player is gonna be attached to this kind of node. And notice that this is our root node, right? Root of our game. And below it, we've got childs, right? Children. This is child for this parent, child for this parent, child for this parent, child for this parent, but this child is a parent for this guy. So this is like a grandfather for, for this guy. But it's like a tree. That's why it's called root. Root is expanding, right? To branches, nodes. Okay, so we've got another branch, and this branch has another branches, right? That's why it's called like this. That's how you can memorize why these things are called so. And now we've got our character body here, but it still doesn't have the sprite that I said, so it doesn't have the image. How do we add it here? We've got here inspector, as I said, it can inspect and change the properties. So the things that describes this kind of node. And this kind of node has got specialized properties, like for example SpriteFrames, okay? So it allows you to add, using the SpriteFrames, when I hit it again, the animation. And as you can see at the bottom here, now we've got animations panel. And we can attach to it, using this button here, add frames from sprite sheet, from our asset, our warrior. And when I hit it, as you can see, we've got here vertical, horizontal lines, but they are like crossing our guys, and this is bad. We need to move it here. As you can see, we need to change it. So we need to, most time I'm just, clicking here and trying to find out what kind of lanes should be used in this particular sheet that I've just attached, okay? So as you can see, oh, it's 6x8, right? Now I am not, deleting anything from these characters. When I do something like that, okay, I deleted here the sword, right? So, okay, it's 6x8. And now I need to choose the animation I want to attach. So I want to attach the idle animation when the knight is briefing, right? He's doing like, okay, it's just standing, right? Here I would attach if he was moving. Here I'm gonna attach if he's attacking. But now I'm just focusing on one particular animation, and I'm choosing the frames that should be repeated. Okay, let's attach it. Wow, we've got our knight here now, and we can play the animation. Okay, so that looks pretty cool, right? We can make it even better. Right now it says that it goes 5 frames per second. So 1, 2, 3, 4, 5. Okay, so it's gonna do this part of animation in 1 second, but we can make it go faster. Now that looks better, doesn't it? Okay. Now when we run our game, we've got our character here, but he's not moving. What's wrong? It's because our animation is on the loop animation. So when it finishes this animation, it's gonna start again, but only in this place. If you want to autoplay on load, you need to choose this thing here. Now it's gonna work properly. As you can see, now we've just added player that is just standing there and he is just waiting for action that we're gonna give him in next lectures. Here we're gonna change the label from default to idle to make sure we, organize things in our project. Idle says that, hey, this is just standing, this is our animation, and we've got our character now with animated sprite. This is not finished because we need to attach a way of, movement, and we need to also add something what is called collision, but we're gonna talk about things like that in future lectures. If you have any questions, as always, feel free to ask, and you must now, before going to the next lecture, do everything I did manually. I did lots of things, clicking and so on, right? You need to do it manually to make sure your brain, says, okay, so this was important. So this is your exercise. Do everything I did. You can attach another warrior. It doesn't need to be red. You can attach whatever you want, right? Maybe you want to attach a troop that is archer, okay? Doesn't matter. Just attach him. I want you to attach a character body here with the animated sprite, not the simple one like this. Hello, let's practice what you've learned in the last lecture. Let's create an enemy for this player. We're gonna use for that goblin that is in troops folder, torch, and we're gonna use, for example, maybe not red guy, but purple guy. And let's move this into assets. Try to do what I will do without looking at this lecture, okay? When you finish, try to see what I did, because I will try to remind you about some definitions that we've already learned in this engine, okay? I want you to practice. If you don't practice, you are not gonna become game developer, okay? So in order to add another guy here, we need to attach to our root place, so to our root game node, right? To the main scene that we see here, something what is called another node, right? So another element. And in order to do it, we can click on plus or Control plus A. Let's remove these guys, okay? And when I hit Control plus A, I can find now everything that is connected to 2D games by typing 2D. And I will choose now CharacterBody 2D because I want a character that is specialized for movement. Maybe I will change my mind later, okay? Well, it happens, don't worry. We could start from something like this because, hey, I'm not sure what's gonna happen later with this body. Will I need to have it rigid, whatever it means? You will soon learn, right? But it doesn't matter. If you don't know, just choose this one. You can change it later, right? Let's say we're gonna use this. And now we need to attach a sprite to this new character body. How do we do it? We need to attach to this thing another node, which is the sprite animated, right? Because we want animation of our tortured goblin. And now when we go to animation, we need to choose new sprite frames, and then we need to hit this again. And now we need to hit add frames from the sprite trees. We're gonna choose the torch guy, and we need to divide it properly. So I think it's like this, 7 on 5 this time. And I'm gonna choose using the shift. So the first I'm gonna click and then shift, it's gonna choose all the frames at once. And now we've got our goblin here, right? Good. We need to auto start the animation. Let's make it a bit smoother. And as you can see, now we can play to see it. That's great. So we've got our enemy and we can move him, for example, here, right? But you probably noticed that, well, we moved this, but hey, this thing, the main node is not in the right spot. So we need to somehow move both of guys at the same time. And this is really problematic, not only because, well, right now we've got what? Only a single enemy. Let's say we've got more of them. So how do we create more of them? Do we create another node and again add animation? That would be horrible, right? If you had to create games like this. Well, you can of course use the script for attaching new enemies, but the ones that the game starts with, I think it's better to put on the main scene, right? But I'm not gonna lose my precious time like this. So I'm gonna duplicate this thing here. In order to do this, I right click and then hit on duplicate or use the shortcut Ctrl+D. So I'm gonna duplicate it. And as you can see, each time we created a new guy, and each time we've got some problems with what? With, as you can see, where the plus sign is, right? And where our body of character is. So it's a problem because later you want to have something what is called collision. So you want to like, hey, this guy hit this one. Okay, so this is that, right? Or we need to take 5 HP from this guy. And if we had to move all the things separately, that would be horrible, right? The second thing that you have probably noticed is that we've got here a player, enemy, and all these things are called the same. So the first thing we should do is to change the name of the node. So if you hit the name and hit the F2 or you double click here, you can change the name of the node. So the name of the component we want to attach to our game. It's better now. Now we should do the same for enemy. And you will notice that the problem is now that we need to now what? Do it 3 times. If I change my mind, I will need to do again it a few more times. What if I add something specific to this enemy again? Like for example, the collision, right? Or I attach a sound. Do I need to now add it to all of these enemies manually? It would be bad if we had to do it like this, right? And that's why we can create some kind of sub-scene, okay? So something that is gonna represent the entire enemy. So we don't need to repeat ourselves, okay? And you will notice here also something like when I move this guy, here is something like this. And if I want to keep this and this together, okay, because yes, you can. If this is just a single node, you could do it this way. You just hit this, group selected nodes, okay, so it means that, hey, I want to group them. And now when I'm moving both of them at once, always. So this solves some kind of problem with the movement. But still, we need to repeat ourselves if we change something to this guy, right? So we need some kind of class. So something that will be like a blueprint for creating enemies, right? We need a blueprint for creating enemies. We created 3 goblins. And even though they have so much similarities, they are not the same goblins. I mean, when you attach now to the enemy 3 a new thing, like for example, I want to play audio stream players. I want to, you know, play the sound of this goblin when I move close to this guy, for example. Then I need to now attach this to other nodes, to other enemies. So this, that's a bad design. To be honest, if it was like this, I would never, you know, create anything in this engine. Well, you could probably add enemies through code if you know how to code, right? But still, even if, notice that the base of your scene, the main game, right, the level that you are, you know, making, you don't want to put enemies that are like, you know, static. They are standing here and they should always be here in your code, because this is just, you know, it will just take too much effort and time. That's why you use this engine, to not do such things from code, right? So anytime you want to reuse something, okay, it's very important, reuse elements. So for example, enemy, or for example, coin, or for example, player, or for example, a resource in your game, the gold mine, or anything that you feel like it's gonna be, you know, reused, then you need to create something what is called a scene, a sub-scene, I would say. So it's like a scene that is gonna be attached to the main game scene, okay? And how do we do such thing? We can click on the plus here and create a new one, but we will not use this method in this lecture, but we will convert the node that we've got here now, so enemy 3, into the scene. So as you can see here, we have something what is called save branch as scene. It means that save entire node and everything included in this node into another scene. So when I hit this and I save it in the scenes folder, you will see that you don't have a way to play with the nodes of the enemy free now, right? Here, from this place. But we've got here this icon here, and when I hit on this, as you can see, we've got our enemy here that now we can play with. And the cool thing about this is, well, maybe let's change this name to enemy because it's like a main enemy now. When I attach here something like, for example, this music, it's gonna be attached to any scene, right? To any enemy that used this scene, okay? So when I do something like, let's copy this guy, so let's delete these guys because we don't need them anymore. And when I hit Ctrl+D a few times, right? We've got here what? This enemy, right? And all of them shares all the things that are here. We can still specify each of them, right? Like, you know, hey, I really want this guy to be different. Yes, you can, okay? But you want to specify only this guy, right? To be different. Or you can change the properties. So in the inspector, you can change for this particular guy something specific, right? For example, the collision that we'll talk about later. Yes, you can still do this, right? But if we have to attach something to all enemies, right? Change some behavior, change the sprite. Like, hey, I don't want this thing to be, I don't know, I want it to be 15 FPS now. So it's applied to all of them at once, right? So this is gonna save you tons of time. That's why you create scenes. So, you know, think about the scene like it's a box that's got lots of connected nodes to each other. Okay, so by connected I means that they are like about the same topic, right? So hey, I want to create an enemy. Okay, so I need to focus on enemy now, and I'm gonna do it here. So to be honest, even if we have only one player in our game, it's good idea to what? To save branches scene and create it as a player. Why? Because now when you want to focus only on player, you're gonna do it from this place, right? We've got only 4 things here now, but later there will be tons of them, right? And you would get lost, okay? That's what will happen. And now, because we put it in another space, we can focus here on this space, on this thing, in this place we are now, right? So this is like a reusable element, okay? So we can connect this, bam, bam, not this, what I did, connect this way, and now move it here, right? And all of them are connected now, as you can see, like this. And I focus only on player now. You could even, you know, send this player, right, to somebody so he can focus on player while you are doing some different things here. And what's more, if you think like, hey, I want more players, right? Why not? There are 2 of them now. And you can specify player 1 and 2 differently, right? Like, let's say that I want different keybinds for player 2. So I will do it from this place, for example. And this is very powerful and probably the most amazing thing about this game engine, that I didn't need to go into script, that we're gonna talk about later, of course, to make many enemies, to make, well, make the creating a bigger game easy, right? So very useful thing. And it's very important to create scenes, right? And also it's important to put them into what? A folder that holds scenes, okay? Not like putting everything in the main folder, right? Because we need to keep everything organized since the start. How to move this character, but of course not from this place. But after running our game, I want to use my keyboard. And when I hit the left button arrow, I want to move left, right, I want to move right. How do we achieve things like this? Well, firstly, you need to know how to instruct your game. And in order to make instruction, so some things like orders of doing something to any element, like for example player, you need to create script. Script is like a small program with instructions to what should happen when something happens. Yes, that's really a good thing to explain. You want to happen things. You want to make things happen when something happens. So when something hit the button, I want to move this guy, right? For example, like this. And in order to achieve that, we need to attach a script to what? In our case, a player, right? Because we want to move player. How to do it? You can do it by hitting this plus button here with some kind of script icon, right? Or you can hit the right click and then hit the attach script. So we're gonna use this method, and then we've got here suggestions about how we want to attach a node script. Firstly, it asks us what language we want to use. By default, we can use only GDScript. What's that? Well, it is a language that was created especially for Godot engine, okay? So this is recommended way of writing programs. But you might be like, hey, I know other programming language, I don't want to learn anything new. And to be honest, you can stick to that, but I highly do not recommend. Because this language is so easy to learn that I didn't even need to learn anything about it after, just opening the first basic script, because it's just self-descriptive. It's very similar to Python, okay? It's very easy to catch and learn. And it's really enough for most things, and especially for beginners. It's like it was created for people who wants to just jump in and play and have fun, okay? So GDScript is easy to learn, and you don't need to learn it on your own from scratch, okay? Because I will show you a way with AI, how to use AI to make a script for you or to edit things. So we got here GDScript, and then it asks us where we want to attach this script to, because we chose what the player is gonna attach to CharacterBody to the node, right? Because this is the thing that describes our player right now. And then we've got a template. We can start from something, from the built-in template, so code that was created by somebody else, okay? And to be honest, we're gonna choose the basic movement because we want to just have a basic movement at the start. And then you can create it as a separate file, the script, if you do not choose this option, or built-in, which means it will be connected to this particular node, okay? But let's do it differently this time. So we're not gonna use the built-in script. We're gonna choose here a path. It's very important to organize everything since the start. Let's hit this arrow here and let's create a new folder that we're gonna call scripts. So we're gonna hold here every script, and we know where to find them, right? It's in the scripts folder. And now when we hit create, we have got here a new editor that allows us to write code. So instructions to the thing that we've just attached our script to, right? We attach it to player, so everything that happens here is gonna happen to player. Of course, you can refer other things, but that's not the topic on this lecture, but this is the code attached to player. And you've got from this place a way to get very easy to things that are set, for example, in inspector on the right side, right? So we can access all these details here, right, from within the script. And there are lots of code written by the Godot engine creators, right? And these scripts allows you to move with the basic movement. That's why it was called basic template. And when I play this, you will notice that our character moves, but it falls down. And well, I try to move fast. Oh, okay, I've moved to the right, but I fell down. And how to change it? Well, you might be thinking, I need to know how to code, right? But think always about each thing you learn, each new thing you learn in Godot, as if it was a mini project, okay? We've just attached what? A script to player, we know how to do it, and we are happy we've learned something new. Now it's time to, for example, understand what this code does. How to do it? Well, to be honest, the best way to understand what it does is to use AI. I pasted the code here and I said explain above code shortly, line by line, for a beginner. So it knows that, hey, he is talking with a beginner and he is explaining everything step by step, what it does. If you know how to program, these things will be easy to catch. If you don't know how to program at all, some things might be still confusing, like for example this part. And to be honest, even if this part is confusing, this is not like a deal breaker, okay? It's not like it's the end, you can't create anything. As I said, try to think about everything that you do now as a mini project. So I've got here lots of lines, and I will notice soon that there is something about gravity. The block checks if the character is not on the floor. If true, it applies gravity to the character's vertical velocity. Okay, so this is why we are falling down. So probably we need to just remove it. So maybe let's do something like that. Let's copy this and I will ask. So if I don't want to fall because my character fell down, I need to just remove this. So we are solving a mini project, right? Oh, okay, so we need to remove it or command it. Command means that we just want to computer to not process it, and maybe later we want to, put this code back into our game. But let's just remove it, for example. So hit this and let's see if it worked. As you can see, our character is standing, and now I can move forward, I can move backwards, and well, we've got here enemies that we can pass through. But this is another problem, this mini problem that we need to solve later, right? Do not focus at everything at once. You are just learning something new. You don't need to have everything perfect since the start, okay? So you've learned in this lecture how to move your character. You've solved this mini problem, but remember, focus on the one thing at a time. When your brain says things like, I can't possibly create a video game with all the things I have to learn, right? Tell your brain something like that. But I can now move my character, and I can now delete gravity, and now I can attach a script. I can do all these mini things. And also notice that scenes are like mini projects, right? Because if I close all these things and I am like, hey, I want to focus today on the player. Hey, I am looking at the player scene and I'm focusing on this mini project of, for example, hey, I've attached the script and now this guy is moving, for example, right? So this is how we solve problems, step by step. I've also made a simple mistake at the start that I wanted to show you so you don't make it in future, and also it make you understand how scenes work. Notice that we've got here a player and we attach to it a script, but here we do not have a script, which means if you want to use this player again, what happens? We've got player 2 that doesn't have what? Script attached to this player 2. So when I hit another guy, there is no script. So this guy can move, they can't. Well, if you want to achieve something like that, that's a good thing. But if you want to create these mini projects separately from the main scene, I think in this case, we should attach a script not to the player, the scene that we've created here, right? But we should attach it to what? To the player scene. So here, it should be here, okay? Not there. And here, as you can see, it says attach a new or existing script. Oh, so I can use the existing one. I don't need to create the script, right? So let's open the file and let's find our script like this. And I will just load it. And now I've got this script attached to the main scene of player, which means when I go to the main scene, which is game, and now I attach another player, right? Oh, another player, it has got a script here attached, okay? So that's a big difference. So remember that you can change the properties and things regarding each new enemy that you created here, or the player, right? To make it individual, to make it, specific. But if you want to apply all things, to apply something to all the objects, all the elements that you create from the blueprint, like a player scene, right? Then you need to attach things to the main scene, not to the thing that we've got here, okay? That's a very important thing to notice while you are creating a game. This guy is moving and, well, he pierced this small guy here. I hope that somebody pays him. To be honest, he's inside of him, right? That's why. But there is a problem because, well, there's like no collision between these guys, right? We can just move through them. And it happens because our right now scenes regarding player and enemy consists of only animation. So it's like image that is animated. That's all. There is nothing else attached to this. And there can be thousands of types of your characters and things that you create as an image, right? As a sprite. So it's your job to decide which kind of element of this image is gonna pierce this guy, right? Or which type of this image is gonna collide, hit it. And how do we define things like that? Let's define firstly our enemy. So when I hit F, I will center everything, then I will zoom in, and here I need to paint the boundaries of the collision. How do we do it? We're gonna attach to the enemy scene a new node, which is called collision. And we've got two types of these nodes, polygon and shape. Let's focus now on this thing. As the name suggests, it's gonna attach a shape to this image, right? That is gonna now collide with something. As you can see here, we have an exclamation mark that says a shape must be provided. And it's because we just added a node which is empty, but we didn't specify it here. As you can see, it says shape. Okay, I'm gonna hit on it. And now there are many ways to attach collision. One of it is, for example, a circle. And as you can see, now we have a blue circle now. And the exclamation mark disappeared. It's because now we, in this place, have a physical body, okay? This is really how our character, the enemy, looks like in the eye of the engine. This is it, not the image, right? This is like the thing that the physics is gonna be applied to, okay? So it's like it's on the head of this guy at the moment. But let's stick to it like this. Let's untie the the node so we can move it, and let's put it, for example, here at the start. And now when we run this, have something changed? No. Why? Because this guy is really this simple blue circle, and it interacts only with other collision shapes. And when we look at our game, we have got now this shape on every enemy, but our player doesn't have it. So we need to go to the player, then to the scene, and then here we need to attach also a collision shape, right? And now we need to choose what type. Let's, for example, this time choose this one, hit F, zoom, and then untie everything so we can move this guy here. And let's say that the shape of our guy is like this, right? Now I'm gonna save it. And this time, notice what will happen. Nothing happened because we need to move it like this, okay? Now I can't move, right? Because here I have got this blue part that meets this circle inside of this, who is that, goblin? And he's inside of him again, but from the back. But hey, he didn't pierce him this time, right? So it's up to us how far this guy can go, right? We can change it by, for example, if we go to the player and we make another collision shape, right? And we make it only for the sword, it will also collide with other things. Or we could, make entire polygon, which allows us to do something like this. Let's do this, and let's do something like this. I want, entire guy to collide. So when I do it this way, you can do it, of course, a bit better, and you can fix later if you do something wrong like this. And now when I run this, notice that, hey, the collision started a bit sooner, right? And also remember that the collision started with the circle, not with the torch, not with anything else. That's why it's very important to understand that this is not a representation of what collides. The image is not a representation, right? The thing that you define here in the background of the scene. I've got a very cool thing to show you. Let's practice a bit by adding something what is called the boundaries of your world. Because right now, when I do something like that, as you can see, whoops, I moved outside, right? But maybe let's make a boundary at the beginning, at the bottom. So let's go back to our script and let's go back to the script where we had a gravity. Now when you can see everything falls down, right? And to be honest, well, can we change it? Can we make it collide with some kind of ground? Yes, we can. In order to do this, we hit on the game node, then we add a new node that we gonna call now the static body. Why is it static body this time? It's because this node is like pre-made for the fixed body that can't be moved by external forces. As you can see, you have got a description. When moved manually, it doesn't affect other bodies in its path. So we want to create a body that is not visible to anybody, right? It is static. We want some kind of floor, right? Just a floor, that's it. And now we've got it where? It is here, right? This is this thing, but hey, that's nothing like this, right? When I open this, nothing happens. It's because it also doesn't have a shape. And now when we attach to it, what? A shape. So the collision shape. And we choose now not these things, but the word boundary shape. You will notice that we've got here something like this. F, zoom, and here is a line. And this line really decides where the collision happens. And you will notice what is funny, that even though this thing is here, it happened to like entire space. Why is that so? It's because this kind of shape is called word boundary shape. It is a special shape that specifies by this line where in the like, you know, horizontal space the boundary is. So when I move it together, like for example here, it's gonna be like from here to here, right? It's gonna be for entire game. And when we hit the play, I can now move here, and I can even jump. And we couldn't jump before because we couldn't, you know, jump in like nothingness. Now we are on the floor, that's why we can jump. We are on something, right? And well, it's specified in the script that we generated before, right? Here is something like that. You can jump only when you are on the floor, on something, like on something that is that has collision, and this is really a floor, right? So this is like a boundary for our floor, right? Floor boundary, for example, right? You can create boundary on the left, on the right side. You can practice as an exercise, but before we do that, I want to practice even more. I want to attach to enemy a script that we've got in the player. So let's do something like this. Attach the script, now the template that we've already used, and let's put it into the scripts, right? And now I am going to, well, play it just for fun, and you will see that now I'm moving all of them at once. Why not? Hey, that's the basic movement for all characters this time, because we attached really this almost the same script here and here, right? But let's remove now the part where we like, you know, do stuff. Do not remove this thing. We're just gonna leave the gravity, because I want these guys to be put by gravity, right? And as you can see now, I can jump on them. I can be between them, right? So the game has started to look differently. But there is also one more small problem you have probably noticed, is that because we put the shape like this here, even though they are on the same ground, they are not leveled, right? That's why for the enemy, we should, you know, I don't put it, for example, here and make it wider, right? Like this, maybe. Or we could, for example, really make a polygon for the entire guy. Well, as you can see now, they are a bit more leveled. So this is like a plaything you need to try. As you can see now, because I made a circle bigger, I got stuck inside. And well, that's good. That I got stuck inside, because, well, normally probably they would die or I would die, right? This is not something that should happen. This we can now, you know, decide what happens when something hits. Hello, my friend. In the last lecture, we learned how to move this guy, but all these goblins here, they've got torches and they want to probably, you know, hit me. They want to look at me. They want to move towards me. But somehow I'm only the one who is sticking the sword in their ass. They are not even reacting, right? And how do we change it? Let's start from, for example, flipping this guy. Like, I want this guy to look at me when I am moving. So when I'm here, I want this guy to look here. When I'm here, I want this guy to look here and this guy to look here. Wow, so many things to do. But how? Well, firstly, normally you would need to find out how to flip things. And how would you do it without AI? Well, you would go to the enemy, for example, and you will need to look for the properties that allow you to do such things. If not, you will need to program it, okay? But fortunately, in animated Sprite 2D that we've attached to the enemy node, we got something here like this. And when we move to 2D scene,
and do this, as you can see, we are flipping this guy. Okay, so that's pretty cool. But is that a solution to our problem? No, because if we flip this guy here, right, we are flipping all guys, and when we move, they are just standing still. So we've just solved one mini problem. How do we make them always look at me and then, for example, move towards me? Then we need to start, well, programming. But fortunately for us, we do not need to know how to program, at least at the start, okay? I will tell you why soon. So when we go to the enemy and go to the script here, we want to, flip things, but how to do it towards the player? We need to somehow refer to him. So many things to do. And normally the noob AI user would go to, for example, one of the AI available like OpenAI and ask, tell me how to make an enemy look in the direction of player when the player is moving in Godot engine. And this is a bit precise and a bit not. Why? Because firstly, he's gonna tell us how to create a player that we've already created, right? How to, do many things that we don't need to. And to be honest, there is another problem that he's extending something which is kinematic body 2D. Notice that we've got here character body 2D. And this is the name of the node that we are using on our enemy, right? It means that we are basing everything on the node that is called like this. It was created by the Godot engine creators, right? And not this thing, which doesn't exist. It used to exist, but in the older version. And to be honest, most time people who uses AI would do something like that. Okay, let's copy this. It's not working. Okay, so I need to copy this here. Oh, it's again not working. Okay, I'm gonna fix this and then this and then this. And this is a noob way of using AI, okay? Because you need to firstly do something like this. You need to set who your AI is. So you're an expert in Godot engine and proficient in writing code in GDScript. Because notice that we didn't even specify the language here, right? But well, default is GDScript, so he somehow managed to use it. But he used the old version, right? So first, check what the latest version of Godot is. And once you have this information, confirm that you are ready, right? And then, from this point on, always remember that you are using the latest version you found. When responding, always base your knowledge on the latest version. Do not answer until you verify there could be no mistake. So, we've made sure that he is Godot engine expert proficient in GDScript and he's gonna use the newest version. Is it enough? No, that's definitely not enough. Why? Because now maybe he's going to extend the character body 2D, right? Properly. But still, he's going to create a player from the scratch, even though he doesn't know if we want to change something here, right? And he is going to replace some things that we maybe need in an enemy. That's not what we want, right? We want to upload a context. It means that we want to make sure that the AI get the knowledge that we have. Context is the thing that we know and we need to share it with the AI. And now I did something like that. Above file has JSON. And how to create this file? Scene, export, this thing here, and now I'm gonna save it, okay? Oh, sorry. Okay, I made this mistake and it's good that I made it because I exported the enemy scene. I want to export exactly game root, right? The main place of our game so he understands what's going on in our program. So save now. Okay, I'm overwriting it because I did it before, and I'm uploading it here using this thing here, right? And sorry for the Polish language here, but you are just uploading this here, and this is the file that uses JSON inside. JSON is just a way of describing things, okay? But I set it to him so he knows how to interpret this file. It's not like he's used to open files that are GLTF. So it's a good idea to say something. Above file has JSON that describes how my game main root looks like. So how my game looks, okay? And auto reflect. So I can ask you a question. What does it mean auto reflection? Well, when you're talking with your friend, doesn't it happen that you get ideas regarding the things that you are talking about during the talk? Sometimes you're like, hey, I'm gonna do this way, and then this. But while you are talking to your friend, when you are explaining things, you're like, maybe I should do it differently. It's because you reflected on what you've just said. And when you say to AI, auto reflect, so I can ask you questions, it means, I need to think. Okay, so as you can see, AI knows now the game structure. So it has got now a context of our game. But that's not enough. We don't want it to create the script from the scratch, right? So I've just uploaded what? Player and the enemy GD. So the scripts, I did something like that. Send, and I've just chosen these two things from the game folder, okay? So AI auto-reflected on our script, and now I ask it how to turn enemy face towards the player when player is moving. And because it knows about our script, it will not do anything to the player now, right? Why would it do anything to it if we want to just turn the enemy? So we do not lose our time to read all the stuff that was here. You just need to copy this part, run the code, and as you can see, hey, they are turning. Yes, that's what we wanted. And to be honest, we didn't write even one line of code. Hey, maybe let's improve it. I want also enemy to move towards the player slowly. It's not like you should write everything using AI, right? And to be honest, it's not like it's possible to create very big game using only AI. But, well, to be honest, you could, but it could get a bit messy if you do not know the process of programming, okay? Notice that everything is described here. So, assuming the player's node is a sibling of the enemy's node. Let's say that I don't understand this part. So I'm going on, I go here. And to stuff like, can you explain it to me like if I had never written any program? Write to me like if I was 7 years old. Let's go. Wow. That explanation. Look at this. Just wow. And you know why it's good? Because I didn't say, can you explain it to me? But I also added a context. I am a noob. I want to be talked to like 7-year-olds. And to be honest, I always like to be talked to like 7-year-olds because I don't like people who brag about their knowledge. No, you should be sharing it. And if you want to share the knowledge, you should talk always like this. Okay? So in this lecture, we learned how to program with AI. And as I said earlier, it's not the end, right? It's like, I want you to know that you can solve many problems like this. Some of them, they can be solved better. But to be honest, for the sake of creating your first game, to have fun, to see for yourself if game development is for you, why would I need to know everything like, how this works exactly, step by step? If you need it, you can, say it to it. Hey, please explain me. I am 7-year-old. I want it to be, easy, right? But there are so many things to learn in this Godot engine that are more important at the start, right? That we can now at least focus on the part that I think is more important. How you feel about this engine and where to click what. How to project your design that you have in your head onto this Godot engine, right? Programming is very important for advanced project. For small, as you can see, if you know the process, if you know how to ask questions, you can really do it with AI. And these guys are moving towards us. They want to kill us. But hey, sometimes we have a problem, like for example, with collision. And how do we spot problems with collision, for example? How do we spot problems which are called in game dev bugs? They are called bugs because, well, bugs are not things that we like. We need to destroy them, we need to smash them, right? We don't like bugs. So that's why they are called bugs. And in order to look for them, we have a process that we called in game development programming, debugging. So we want to find it and debug to annihilate it, right? And here we have a tab like this. And now, as you can see, we can choose, for example, something like that, visible collision shapes. And now when I run so now I can see the shapes of these guys. And for example, when we had a problem like this before, I can see why it happened, right? Okay, now I can see because I didn't get into there. I can spot things now. And well, to solve this, probably I need to do something like this, right? So let's make this a bit smaller. So because of the change, I could, run out of them. I didn't get stuck there. But let's go back to what we did in the last lecture. Notice that we flipped this guy, right? Well, that's pretty enough when you are using this type of collision. But what if we had used, for example, something what is called collision polygon 2D, which allows us to, specify exactly the points of this guy, right? For example, like this, okay? It's not like you need to do it this way, okay? Let's delete this part. But let's imagine a situation like this. As you can see now, what is changing? Only the animated sprite 2D is flipped, right? Using this. This thing was not flipped. So we've got a problem. You might be saying, hey, this is not a problem, but let's make this nose bigger. I didn't have time to. Let's make it a bit less big. So something like this. So I can now stand on his nose, right? And also there is a problem because, well, they also collide with each other. They can't move next to each other. And this nose is not changing the direction, but it should, right? Why it's not? It should change it. So how do we flip it when there is no flip button here? That's a big problem, right? Because, hey, how do we flip it? And notice that animated sprite, it has got it, this doesn't. But why? And this is a very good question. Because when you go into all nodes, notice that the node that is at the top of all nodes, so this is like, as you can see, something that expands everything. It is the base for all scenes. Then we have got the viewport that we haven't talked about, and we have got something what is called canvas item. Canvas item is any item that we've already used for creating, like for example, animated sprite, the collision, and so on, right? So this is like an item, element, that we put on the scene, on the canvas, on the thing that people see. And this is like something that is used for grouping only. And then here we have something what is called node 2D. And this thing is now a bit more advanced because it says it has a position, rotation, scale, and Z index. And everything that node 2D can do, any of these guys below can also do. What does it mean? It means that when we go to collision polygon 2D, this guy can do what node 2D can do, okay? Animated sprite also can do this. And anything new is programmed by somebody else, okay? So it's like somebody extended this and now he can do flipping, for example, here and adding the sprites, which are animated. But here we have something for creating the polygon for collision. And that's how it works. But why then somebody could flip this? How did he achieve it? Well, when you go to the collision polygon, you will notice that we've got here a transform in the node 2D part. Notice that animated sprite 2D has node 2D, the collision polygon has node 2D, and also it has canvas item, it has node, right? Notice that all the things that were the parent for the collision polygon, right? So notice that when we go to the collision here, right? So this thing has got everything that this has, this and this, right? Notice. Okay, I have access to node, canvas item, node 2D. And this is like specialized node, collision polygon 2D that has this. But to achieve whatever the guy achieved here, he based on this thing here, on node 2D. Because notice that we have got here something what is called scale, and it allows us to scale things, which means get it bigger or smaller. When you want to go to the default value, you hit this thing. And then, if you want to flip things, you need to type here minus before the number. So when I hit -1, you will notice that we flipped it, but we also flipped it not only horizontally using the X, but also vertically using Y. Why did it happen even though I only typed it here? It's because we have got a chain here. When we unlock this chain, now when we change something to this, as you can see, we change only X and we flip this guy. So really, somebody who made this property here, who created this thing, in the background he is just using the scaling and he just changed the X to the minus value, and that's all. Fun, right? And well, we can do the same now. And to be honest, when we go to the script, we can solve it, of course, using AI, right? Notice that I ask, collision polygon to do doesn't flip with animated sprite 2D, change it please. And oh, okay, so you need to do something like this additionally, and here is the rest of the code. I can now copy it and it works fine. So you wouldn't need to, write it. But even though this course is mainly about AI, I want to show you the process of thinking, because you need to know how things tie together. Otherwise, you won't be able to even properly ask questions to AI to get the response that you want, right? And I also show you that programming is not really that hard. So there is a lot of code here. Do I need to understand this code in order to just change the part that we are looking for? So we are looking for what? For flipping, right? And we've got already a code that does it. So notice here. Do you see anywhere flip? I don't. So let's find it. Oh, okay, so it's here. And remember that any line here is like an instruction, so it's really like telling what computer must do. And this flipping thing happens here. So it means that, yeah, it happened here. We told computer to access this guy, animated sprite 2D, and then access what? Flip edge. And then we change it using the equal sign to true, because on means true, false means off, okay? And otherwise, we change it to false. And Well, this is a condition that checks what's the position of the player, okay? Based on the enemy rotation. How it works, do you need to know? Well, not so much, right? We just know that it checks it. And to be honest, you can ask how to check things like that using AI. Because for physics, for things like math, hey, you don't need to reinvent the wheel. Really, all these things can be answered by AI pretty fast. It's like really good at it. So you know that this checks if the player position is good and it updates the enemy rotation, right? But we also want to update the data collision. How do we do it? We need to select this node, this element, put it here, and then use the dot, right? And afterwards, we need to access what? When we are in the collision, we change the scale x value to -1. So let's access scale. And now let's assign here -1. Let's see what will happen, okay? When I run the code, you will notice that it crashed. We've got here an error. It says invalid send index scale. And it means that we assigned a value that was not expected here. Because notice that when we are looking here at the scale, it has two values. So to be honest, it stores two values, not one. So if you want to change that part of the scale, you need to access it. So with the dot, we access x. So to be honest, it's like a path, right? We access the collision polygon, then the scale, then the x, and we change it to -1. And now you will notice that we need to stop the program, run it again, and hey, they change the direction, but only once. Hey, but we are moving forward. And that's how you program, really. It's not like you do not make mistakes. You make plenty of them. So otherwise, we need to set it back to 1, right? The same way as it happens here. It flipped to what? To false, and from true to false, and now we need to set it back to scale to 1. And now as you can see, what happens? Hey, everything works like we wanted. The collision is also changing the direction using the scale part. And well, AI solved it, of course, faster than us, but it's because I had to, tell you how things work in this engine. But you should understand now that it's not like you always need to depend on AI, right? You don't need to always depend on external sources. Play, make errors, because it's normal. You have got this debug menu that allows you to see collision shapes, for example, to see what's going on. Now, as you can see, we don't need to see it. And when we go to enemy, we need to change this pointy nose now back, right? What's more is important, really, again, is that it's worth learning programming, even if AI does most of the job. Because things like this, you can change really very fast, right? If you understand what's going on in this editor. And it's not like it's gonna be faster if you copy things here. For simple things, I highly recommend using this. And also, not only for simple, but abstract things. Because, right now we are accessing, for example, this variable here. But it's not the best way to do it. Why? Maybe it's not the topic for this lecture. But these things can be written better, more universally. AI just solves a problem because we asked for specific problem, it gave us specific solution. And we didn't ask how to, properly put this project firstly, right? We didn't ask her how to analyze it. So there are some, things that we could write better, for example. We can ask her now. But you need to even know that you should ask about it. And to be honest, that can be a good exercise. Ask her, what can be written better in this course? How to make it more universal, right? Maybe you learn something about programming. Remember that ask her at the end to explain things like to, for example, 8 years old. The explanation will be 10,000 times better. Our player is moving, but is he really? Look, he's like standing here waiting for a bus. Nothing is changing. The animation is idle, right? How to change animation from one to another. After this lesson, you will know how to do it and how to use AI to help you with that, even if you do not know how to program, okay? First, we need to add a new animation to our sprite frame. So when we choose the animated sprite 2D, we need to attach a new animation. As you can see here, we have a box of all animations that are attached to this animated sprite 2D. And now let's call it, for example, walk. So we want to change from idle to walking. And then we need to choose what? We need to choose the asset that we are using. Then we need to change the settings here, like this. And now this is movement, right? You can choose more than one if you click left click here and then shift. So I've got all frames at once. And as you can see, let's improve the FPS and let's play it. He's moving, right? But the problem is that this is the animation that we start our game with. That's good because he's just standing in one place. But hey, I want to walk, right? So I need to change somehow from this to this from within the code. Based on what? Based on if the player is moving or not, right? So as you can see, it happens when I am using my keyboard, right? And this is detected in this place. So probably I need to put it somewhere here. But because I do not know how to program, right? Let's assume this. We're gonna go here to AI and ask her, I would like player to have different animation when he's walking. Change animation from idle to walk. So I specified what? That I want to change from this to this. And well, I can just copy it and paste it here. It knows how to answer. Remember why? Because in previous lectures, we were talking with it and we made sure that we gave it a context, right? So we gave him all the details about our project. So I send it what? Scripts, right? I send it our tree, right? Using the scene export here. So I gave him all the context. So he knows what's going on here in our code now, right? And that's why he could precisely do that. Try to, as an exercise, ask it without, you know, the talk from before. You will notice that the difference in answer will be tremendous. So now when I play it, as you can see, he's walking. That's great, but he's only walking towards them, right? And when I'm moving backwards, he is like, you know, not changing direction. So, hey, I don't know how to program, so I'm gonna ask. That's great, but my player do not face where I'm moving him. Can you make him face towards where he moves? Okay, so he's going to do it. Let's copy it. Let's see if it works. As you can see, it works fine. And wow, isn't it cool that AI did so much stuff for us? But now I want to, even though AI did everything for us, I want you to understand a bit of this code. Because it will be easier for you if you understand the process of this thing. Otherwise, you will have problems asking good questions to AI in future, okay? Notice that this part is like place where the change of direction of the player happens. Why? Because we check here if the direction changed, okay? This is like, let's check. And if it's left or right, this thing is gonna be executed, okay? Which means that we send to the computer that we want to move this guy with the velocity, so how fast, this thing. And then here is the thing that it attached. It said that we want to access animated sprite 2D, but where is that? Why there is $ here? Notice that from the player script, we can access, for example, this node this way. Bam! As you can see, bam! Okay? And now we access something what is called play. When I hit Ctrl+ left button, you will notice that we jump to play. And it says that it plays the animation with the key name, okay? And this is one of many things that can this animated sprite 2D do. As you can see here, you have something what is called methods, which means what can be done with animated sprite 2D. And here we have properties, which means what can we change regarding how it, for example, looks. So for example, here we have something what is flip that we're gonna talk soon about. And when we go back to our script, notice that we invoked, which means that we accessed the play method that was written by Godot creators, and this thing just changes this to this, and it works because somebody made this method do such thing. You don't know how it's done that it changes from this to this. It just do it, right? And it's very important to notice what I've just said. You don't know how it's done. It's done by somebody who created this method. And you see, here we have got something like flip the sprite based on movement direction. And well, it does it by doing something like that. Notice that we've got here in the animated sprite something like this. Flip. So you can see I can flip it. So yeah, okay, that's cool that I can flip it. But how it's done here? We just change the value from true to false or false to true. But why in this particular place? Why should I check if direction is like this? I do not care. Notice that when I get it here, and I will say it like this. Can you change it into separate function and make itself descriptive? You see my point. So why it's very important to understand that you don't need to really understand each instruction when you are trying to achieve something. So I am taking this into our code. So instead of having this, right, we have got now this function. And it says flip the sprite based on movement direction. I do not care how it's done. It does the job. Okay? And we just like moved this entire code that was here, right? It was here, right? So we moved it outside into this function. And now I just don't care. Just please flip the sprite based on the direction that I sent here, right? I send direction. I do not care. Does it do the job? Yes, it does. That's why when you ask AI for solutions and they work, you do not need to precisely understand sometimes how do they work. But there is a small catch. Things that we write here, they are not like super elegant, right? They are not like, good way of writing code when this code is gonna get big, for example. There are many ways to improve this code. But when you are learning how to code, when you are learning a new tool, you don't need to have perfectly everything. To be honest, it's best when you just make your things so they just do not work. Why? Everything should work instantly and everything should be perfect. No. You have to make mistakes in order to learn. Because you will notice that when you write code that is not easy to expand after you create your first game, you will understand why you should do some things that many instructors are talking about. Otherwise, you will just memorize some things and you will not know why you are using it. And you will really feel like you are not doing anything on your own, right? It's like, it's not you that was the person who invented this solution. You don't understand it, you are just using it and you don't know why. And that's why you also don't know how to go further with your game. Because every time you need to go back to the tutorial that you've watched, right? No, this is not a way of learning things. As I said in the previous lectures, mini projects, step by step. Now we are accessing, for example, this thing this way, right? Because AI suggested it, but there are many other ways. You could, for example, put this using the control shortcut and access it from here. And then you can easily change this value to something else, for example. But really, these are advanced things. You don't need to know this now. For now, you should be happy because look, your player is moving forward, backwards, right? We are one step ahead. And try to do the same as an exercise to the enemy. These goblins definitely want to set us on fire. So let's run to the left. Oops, we are not visible anymore. But we can come back. Focus now. Because what I am about to say is very important. The size of your game is determined, so it is set by these lines here. This is called view, which is what the user sees, views, when the game starts. If we move our goblins outside, what will happen? Let's see. Will they appear? Yes, because they were outside of the view. It's not like they were not in the game. So your game is really like unlimited here. You need to set where is the boundary of your game. We already have one boundary at the bottom and we set it in previous lectures with the static body, 2D, and the world boundary shape. Because of that, our player has a place where he can stand. Without this floor, our player would fall down and keep falling to this unlimited space that we have here, right? It means that you can expand the world of your game in any direction, left, right, top, bottom. You have unlimited space here. But how do we make this player to be followed by what the player sees? We need to set something that I'm gonna show you soon. But before that, I want to show you a very important thing, how to change the size of these lines. Because, well, not always you want to start the game from the size like this. In order to change it, you go into project settings. Then you choose from the display window. And here you have something that is called Viewport, width and height. And if you change this to, for example, size like this, our view got bigger, right? But we still can't follow the player. We need to change it, right? We need to like attach something that will follow the player, like a virtual camera. And in Godot, when you attach to a node, like for example player, using Ctrl A and typing here camera 2D,
As you can see, we have got now here a new node from now on. And this node is set initially to the size of the game. As you can see, this rectangle, it has the same size as this, but it is what? In different place. It is set to what? To player at the start. And this means this is the center of the camera view. So this is what player is going to see. Please notice that we have got here 3 goblins and they are outside of this purple thing. And they won't be visible, even though we are within this rectangle that we talked about before. Because after we set a camera to player, this is what the user of your game will see, not this, okay? So when I play it, we do not see goblins, but they will come soon to us. You have probably also noticed that it didn't seem like we have fall down, right? It's because this camera is like moving and following us, right? So it was like this. We fell down, right? And the camera also moved down like this. Huh? So they are moving like together now. We could stick this, so it's like this. We opened the game and it was like, yep. And we didn't notice it because we don't have a background. But if we put, for example, mushroom here, like this, okay, and play, you will notice, okay, we fell down. We didn't have like something that we could relate to before. So these guys are outside of this scope now, right? And this is camera. We can zoom in, for example, the camera when we do something like this, okay? Like, hey, I want it to be 2 times like this. And as you can see, now the size of our game is what? Is the size that we set before, right? So we set it in the project settings and display and window, but the camera view is, zoomed now. We zoomed in. This is what we see. That's all. So now let's put mushroom, for example, here, okay? And again, one more here. So as you can see, we can see one mushroom and we are moving towards another mushroom. Also notice that this is gonna follow the player node, which means that we don't need to do it like this. We can set camera in different places, like for example, this way. And this is okay because notice that sometimes the player is not like in the middle of the game always, but he's at the beginning, for example, right? So let's make the camera floating like this. Okay. So I'm not in the middle now, but the camera is like looking here always when the player is moving, okay? If you want to make your game look like this, not like this, you need to learn and understand what are tiles. And that's what we're gonna talk about in this lecture. You will understand what is tilemap, what is tile set, how it differs from each other, how to use them efficiently. A tile is like a puzzle piece that you use to build an entire game board. It is like a floor tile, but in a video game. This is a tile that I can choose and then I can paint on my map of the game. So this is like a basic part you use to create the background in a game. You will not create games with just a single tile. You need to store them in one place, in a map of tiles. That's why we need to create something what is called a tile map. In order to do it, we choose the main node of our game, then we use the Ctrl+A and we choose the tile map here, create. And now we created a node that can store something what is called a tile set. Tile set is a library of tiles that helps you design levels in a game. So when I choose here this empty and I hit new tile set, you will notice that we have got here a grid. And this grid represents how big each square is for the tile that you're gonna put on your map here. By default, this is set to 16 by 16 pixels, but you can increase it and you should increase it to the size that was provided by the assets creator. So in our case, it is 64 by 64. So I'm gonna change this to 64 by 64, and as you can see, the size has increased. Notice what is written here. This Tilemaps tile set has no source configured. The tile map is something that you use to paint your background. You paint from tile map because this is the place where you have all the tiles chosen from the tile set. Okay, so now we need to change this into this and select the source of the set for our tiles. And we are using tiny swords from the previous lectures. And now I'm gonna do something like that. So drag and drop.
and it asks us, do we want to automatically create something what is called atlas? When I hit no, you will notice that now we need to select which tiles should appear in the tile map for later when you want to paint. So if I choose, for example, only this one, and now I go to the tile map, as you can see, I can't choose any other than this. As you can see, this is the only thing that I can choose and instantly paint if I want. Ctrl Z to go back, or the right click to remove. We can, however, do something like that. Create tiles in non-transparent texture regions. And as you can see, it will automatically choose tiles, so the things in this grid, right? The pieces that can be used as the one for the painting. And now when I go to Tilemap, as you can see, I can choose any of them. If you want more textures in your game from different sources, now you can attach to this set of tiles another texture this way. And now we're gonna choose the automatic option, which removed the transparent parts automatically. So remember, this tile set, it's very important. This is the place where you set up, okay? You have set up here, label. So this is the place where you set how your tiles behave, and here you paint what you've chosen from before. But what do I mean by setup? You see, there are many things that you can change regarding how each square, how each tile affects the player, for example. Let's see, here you have something what is called physics layers that we're gonna talk in future. You can choose, for example, that this part here is gonna collide with player, okay? Only this part. And you can set up it in the tile set, right? You can't do it in Tilemap. In Tilemap, you are just using what you have done in the tile set. Let's paint something on our map. Let's say that I want to paint this. What will happen if I paint it? Notice that we have just removed our player from a game. But hey, you can come out from outside of these tiles pretty easy, but everything is behind it. It's because everything by default is on the same layer. It means that they are like on the same level of displaying things. But if they are on the same level, then which thing should be drawn first in our game? Always, when you have a node, everything is painted in the order that you put here. So we painted the player first, then enemy, then the floor, and then the tile map. So in order to change this order, we gonna put the tile map at the start. Now tile map is always drawn as a first thing. That's why when I open it, you will notice that we are on the background that we have just drawn. What are the other ways of painting? Because, well, this seems a bit slow. You can choose from here, as you can see, different options: line, rectangle, the bucket. And when you choose one of them, for example, line, you will notice that when I choose this, I will just make entire line. If I choose the rectangle and, for example, this, I can paint more at once. I can also have a bucket, which is gonna like fill something up. So when I do something like this and I remove this part, you'll notice that I can like fill everything around it. But this thing is not fast anyway, because, well, this is still manually creating your entire map. There are ways to improve this. So let's say that we finish this, okay, like this. Like this, let's finish it. Let's say that I like this pattern. Let's say that there are many other things on this place and I want to replicate it. How do we do it? We need to choose this entirely, but to choose we need to change the painting to select tool, so S for the shortcut, and hold the left click. And as you can see, now I have a blue rectangle here and I can do something like Ctrl+C and I can paste it into the patterns, okay? And now because I have it in the patterns, if you can see, now I can choose this pattern and draw it anytime I want. But remember that you are in the select mode. So we need to change it again to drawing. And as you can see, now I can just like replicate very fast things that create some kind of pattern that you want to repeat. But there is something even more crazy, which is called terrains. Here you can do something like that. Create a terrain set, add element.
And again, add element, and you're gonna name, for example, the terrain that you want to paint, like for example, grass. And now when we go to the tile set to set up things, right? Because we are like installing, we are setting how our tiles behave. And you go to the paint mode here, you can change how property of each tile differs from other tiles. So it means that I can select now terrains and choose the terrain set that we've created here. This is terrain set 0. And here, as you can see, we have grass. And whatever I do now here, as you can see, this is the color that is here. Let's go back using Ctrl+Z, and maybe let's choose for grass something that represents grass, right? So something like that. And now I can say like, hey, this is grass, okay? Okay, so this is grass for my terrain. I can create another terrain, sand, and here it will be something like this, right? So now I change it to sand, okay? And this is not enough because terrain is something that allows you later to replicate things. As you can see, when I go to Tilemap, you have got another tab, terrains, and this is empty now, but we can precisely set how things repeat. So when I have here in the setup mode grass, and I choose, for example, this like this, when you make an error, use the right click. As you can see, when I choose the places where the grass is, so you do not choose something like that because there is a grass and also the corner. What will happen when I go to the tile map? I have got all the options here, and when I do something like this, as you can see, I can paint. But the cool thing is that when I attach new things, they're like connecting to each other. I can also paint it like this. Wow, this is powerful, right? But if I paint a single one, as you can see, this is only a corner because we didn't set all possible variations. Look, now our algorithm that is behind the scenes of the program knows how to behave when we are painting something bigger, okay? But if we do now it this way, as you can see, it will know also how to paint a single one. So we should do also something like this, right? And now when I change it to sand, I need to do the same thing here. And now when we go to the tile map, I can also paint what? Sand without any problems, right? I can paint it in the line. I can paint it, you know, as for example, something like this. Let's say something like this, and I want to fill up. That's great, right? It's super awesome because it saves you lots of time. Sometimes there might be mistakes, but you can, fix them pretty fast. This is improving the speed of designing your future game level. I shouldn't be able to pass through one land to another without a bridge. In order to make it impossible, we need to attach to a tile collision. How to achieve something like that, and also how to make it quickly, not manually, slowly painting each corner. No, there is a really cool feature in Godot engine that will allow you to do it faster. And I'm gonna show you all that things in this lecture. Let's go! Choose the tile map, and then in order to attach a collision to a specific place in your tiles, you need to attach something what is called a physics layer to the tile map. And here you have something like that. Let's choose add element. Physics layer in Godot controls which objects can collide with each other. We're gonna talk about these layers, what to click here, in future lectures deeply. For now, this is gonna work, and as I said in the previous lectures, we want to make mini steps. We don't need to learn everything at once. How to attach now this physics layer to specific tile. Let's choose tile set because we want to set up, we want to change the behavior of the specific tile. And now there is something what is called painting here, and it allows you to paint on properties, so for attributes of a tile. And here I'm going now choose something what is called physics layer. And this is the thing that we have created here. Notice that if I delete this, there is nothing to choose from. When I add it, now I have got the physics layer 0. And now we can paint. Let's move this using the right click. When I hold right click, I can move here. Let's paint, for example, here, collision. Now go to the debug, visible collision shapes, and now let's play our game and let's see what happened. notice that we have got here collision that we can't pass through, right? And only on the tile that I attached it. But this is very important. Notice that, well, we can't go further, right? It's like, I don't think that the collision should end in this specific place. So in order to change it, let's go here and let's change the size of this collision for this specific tile. As you can see, we have got here points like that. We can move them using the left button. You can hold and move them. And I think something like that is gonna be pretty cool. So now when I paint it here and I play, as you can see, this looks better. I can paint it on other tiles too, for example here. But the problem is that each time I paint it, notice that it is like not placed in the proper place, right? So we need to change it by moving these little things here. But there is a faster way to achieve it. And notice that we have got here 3 dots and there are shortcuts in order to what to do to the collision that was created in this specific place. So I can, for example, flip it. As you can see, I can flip it right, and that's why now I can fastly print it here, right? Pretty cool. So in order to create, for example, this place and this place properly, I'm gonna hit R and again R. As you can see, now I have all the corners pretty fast without having to play here. So how would I achieve making this corner? Here, I need to attach a new point and move it here, for example, another point and another point. So once I need to create a corner, right? But only once. Because when I paint it, I can now rotate it. That's pretty cool, isn't it? And now when we run our game, the collision is attached to every corner. Let's remove the floor boundary from the last lecture and let's see what will happen. As you can see, we've fallen down. Hello, my friend. In this lecture, I will explain you step by step what are layers and how to use them efficiently in Godot. What I am about to say is very important, so focus. After you draw something on blank sheet of paper, like for example this, and you decide to put another thing like this, everything is like on the same sheet of paper, so we overwrite all the things behind it, right? There is no way to decide which thing should be drawn first. We can't like move forward now what? Our yellow triangle, right? It's not possible because everything is on the same sheet of paper. And in Godot, by default, everything is on the same sheet of paper, but the order of drawing is decided by these nodes here. So, in our case, the first thing that is drawn is Tilemap, and afterwards, the player. If we put player before Tilemap, he disappears because the game will just draw on the player Tilemap. So the order is decided like this. But this is not always what we want. Sometimes we want to change the order and we can change it. Like for example here. Here is ordering and by default everything is on the same Z index. You can say this is now 1 and when you go here this is now 0. So it doesn't matter now in which place it is put, right? It doesn't matter where our player is now. He is now gonna be drawn first. But it's because we set it on different level of the index. I will show you now something super interesting. Notice that when I draw here water, so between one and another ground, what will happen? We've got here really some kind of transparent background behind and it doesn't look good, right? So it would be great if we could somehow paint it behind the grass or behind the sand. Can we do it? Well, there is a problem because anything that is in this tilemap is really on the same level of layer.
So it is like the same sheet of paper. We replace whatever we draw here. How do we solve it? We need to create a separate layer for water and separate for ground. How do we do it? In Tilemap, we have got here a property that says layers. And by default, layer 0, which is here that you can choose from, is called 0, so nothing. You can change it and type here, for example, ground. We can now add another element and let's call it, for example, water. But there is a problem. We painted water before on the layer 0. We need to remove it firstly, okay? And now we're gonna paint it on the water layer. As you can see, the color here changed to inform you that we are right now on different layer. And now when I paint, for example, water like this, hey, it looks the same as before, nothing changed. No, something has changed. But the order of painting in our game for layers is always from the top to bottom. So the game painted ground and then the water on the ground. If I hit this arrow here, now water is painted first and then the ground. It is super important to remember to always paint on the layer that you want to paint on. I know that it seems like super easy thing, but notice that when I do something like that, we are on different layer. And to be honest, we achieve what we wanted because water was like, is now gonna stick to this water. But we have now water on the ground and on the water layer in the same time. And why is it a problem? Because when I decide to remove water from somewhere, now I can remove this part, right? Because this is on different layers. So in water layer, I can remove only things that were painted on water layer, right? So this can cause some problems. Fortunately, in the newest version of Godot, it is going to change. How? Well, first let's save our tree for the tilemap because we need to import it soon. Instead of creating a tilemap, as you can see, it is deprecated in newest version, which means it is not gonna be removed in future. You can use something what is called TileMapLayer. Okay. Now here I can quickly load the tileset that we used before. What differs between these two layers now? Well, the name is different, but there is a big difference. Here we have layers, but here we do not have layers property, which means we can't now have two different layers in the same tilemap. And this is super cool. Why? This thing, this layer can be now, for example, tilemap ground, okay? And I would not have here water. I'm going to remove water from here. I'm going to create another tilemap layer, okay, like this. And I'm going to put them together, okay, into node 2D. So they are grouped. So I can see exactly, hey, here are tilemaps, okay? So because I have tilemaps here, I do not need to call them tilemap ground now, but only ground. And here I'm going to call it, for example, water, okay? And now, here I know that I'm going to print ground, and here I want to print what? Water, right? So we need to apply water here. So let's set a new tile set for just water, right? 64 by 64. Tile set, water, automatically, right? And now when I want to paint water, this is instantly on different layer, okay? Let's hide this for a second. And now let's try to do what we had before. So let's go into terrain. Let's put some grass here, right? Like that, for example. Let's put some sand. And let's see how do we attach water now. So we go into water and now we can choose this water here and paint it, right? Like for example, this way. But somehow there is now the same problem. No, remember that the order of drawing is from top to bottom. So we painted ground and then the water. But now in order to change the order, you need to just move the node. And this is cool, very cool, because you don't need to go into properties. You can clearly see what order things are drawn in your scene manager, right? You can just see, okay, so water, ground, that's all. And when you are printing water, you go to water. Okay, so I'm going to print water now, right? Okay, I need to put some ground. Okay, I am putting ground now, right? You can decide what is put in what time, right? You will not make the same mistake. And what's more, you can now jump between these layers, right? You can like, okay, I need to put water now. Okay, so let's go to water, right? Or I can go back to the ground. So you can jump between all of them, or you can select all layers at once. This is super cool. So now if you decide to have objects, for example, you put here another tilemap layer, right? And you decide in which order the objects should be painted. I think that they should be painted on the ground. Okay, so first the water, ground, then objects. I can clearly see without having to go, you know, here, then look here. And in the same time, I can make a mistake here. This is prone to mistakes. This, no. But this is only available in the future versions of Godot. You will learn how to apply this into this game and also how to make it possible to move up and down. And I will show you how to solve movement, how to solve the script like this using proper prompts to AI. We've got our player and he can now move using something what is called UI left and UI right actions. And all these actions come from something what is called input. So you put into the game the action from, for example, controller that I'm holding, or from, for example, mouse or keyboard or any other device that can put in the game actions. And UI left is defined and UI right is defined by Godot creators, and it is visible in project settings, input map, and here you have something what is called show built-in actions. And as you can see, when we move here, we have UI left, UI right, but you should use UI left and UI right for things that are responsible for user interface, not for movement in your game. So it means that we should create our own actions that will be responsible for player movement. So let's turn off show built-in actions, and here in input app you can add new action name. Let's call it, for example, move left. Let's click on add, and here as you can see, no keys are assigned mapped to. Mapping means assigning something. So in our situation it's assigning keys to move left. And when I click on the add event, I can listen for the input from my keyboard, for example. So when I hit the left key arrow, as you can see, I do not need to find it somewhere here filtering. It just listens to the input and I hit accept. Now I hit A because why not? Let's use also A shortcut for left movement. Now I have got my Xbox controller, and when I hit another time the joypad left button and then the joystick left. Let's practice it. So move right, add, plus, now it's listening. So I'm adding all the movements. All right, we have got now all movement types. And now I will make something funny. I will make a screenshot, but why? Because I need to give context to AI. Otherwise, it will not be able to properly write code for us.
So I'm pasting the context, like what actions we have. I will explain what I have just pasted. The screen above shows movements, actions I have defined, okay? So I just informed AI from the previous lectures that have context of our entire project. Remember, this is very important that it has the context. And now I'm just adding more context that I did something that AI didn't see, right? Because I added new actions. Can you apply these actions to our current player.gd, right? Because that's how it's called, right? Player GD, and make it possible so the player can move also up and down diagonally. Remember, super important thing is that there is context, right? Otherwise, it will give you lots of weird code that probably will not work. When I copy it into our game, into the player script, right? Well, sometimes errors like that happens. Why? Because AI sometimes uses old API. So these are errors that happened. Please make sure to check internet before fixing the code. And then we can now copy it to our game and let's run it. As you can see now we can move up and down, everything is working properly, but we need to remove our floor boundary so we can move further. Like, okay, now we can move everywhere, right? And there is some kind of like leftover from the movement speed. This should fix it. Yeah. Okay, it's fixing it. I could ask AI how to do it. That's why it's good to know a bit about programming sometimes. And now notice that we need to also make the goblins to move towards us. So how do we do it? Let's go to our enemy script, right? And now let's ask AI. So can you make the enemy GDScript currently make enemies follow the player vertically in any direction? Remember to check internet. It's good to always add this at the end so he has, like, you know, the newest knowledge regarding Godot, right? But it happened to me that sometimes when you tell it to use internet, it will get to people that had problems and didn't solve it. So it's not always best idea, but hey, you know, it really depends, okay? As you can see, enemies are now following us. How do we go from this to this? So our character can show up in front of an object. Let's use 3 from our assets and let's put it into assets folder, okay? And now let's create a new scene and let's call it, for example, 3. Let's save it. Let's save it into the scenes tree. And we need to create animated sprite 2D. Why animated sprite 2D? Because this tree is really something that is having an animation. So let's make it idle, automatic, 10 FPS because it is going to be pretty fast. And let's choose our tree. Now we need to set up our frames. We are not gonna choose this too because they are for chopping. This is just for the movement because of wind. And as you can see, our tree is moving. So we've got our tree, and when we go to our game and we attach the tree scene, you will notice that we've got something like this. And now it doesn't matter where the tree is, our player is always behind. So normally we could just change the Z index or, for example, the order in which we place things, right? But the problem is that we want to change the drawing order based on the position of our player or tree. So we need to somehow focus only on vertical sorting, right? Only on vertical one, because we want to sort them by vertical position. And you can set vertical position on each object in the scene manager by using something what is called offset. So when we have got, for example, tree, you have got here this plus, okay? And this thing is called offset, and you can access it using this offset property. You can change in it
X position of that plus and Y position, and Y position is really this Y axis, okay? And when you change it to, for example, 30 pixels, we move the plus sign 30 pixels, right? And this changes the order in which nodes are drawn in vertical sorting. How it works, I will explain you soon. Notice that we have got a plus sign here for the player 2, and this is an offset for player character. 3 has got now that plus a bit higher, right? And normally, if the plus sign is below, the player should be shown if the offset of the player is below the offset of 3, right? However, if we move him upwards, so that plus sign is now below the offset of the player, now the 3 should be in front of the player. But in order to make the offsets sorting work, we need to enable it in the root of the things that we want to sorting work on. So in our case, we want to affect player and 3, right? Both these nodes. And to do that, we need to select game and then hit ordering and check Y sort enable, because we want to what? Enable sorting by Y axis. So by this Y thing that we set here, right? And now notice what happens. As you can see, player is like in front of 3. As you can see, plus when it's above, instantly disappears. So this is the way to use it. But hey, we need to, play around it, because I think the player should like be here and he should be invisible still, right? So we need to move the offset where? Down. And if you want to move the offset down, we need to type here, for example, 30. I mean minus 30. Because if you are moving down, you need to type here minus, right? Well, maybe 50. Oh, okay. That should be enough, I think. And now notice that what happens? Bam! He disappeared, right? So when he's like coming from this place, as you can see, okay, and he appears when he's moving like in front of it. So this is like, you need to play with it, right? We need to also attach here a collision. So let's attach collision. We have got 2 exclamation marks here because 3 is not the body type node. So we can change the type, and let's make it static body because our 3 is not moving. We don't want to move it. It's a static body. And let's put here a circle like this at the bottom, so the player can't move past it, right? And now when we play it, as you can see, our player can easily go behind, right? But when he he's like in front of it, he can like show up. But you have probably also noticed that collision polygon is not working good in places like that. So we're gonna change the collision shape also here to the circle, because it is totally enough for the collision to be small like this, okay? For the player. Otherwise, we had a problem because, well, we couldn't be like totally in front of the 3. Right now we can stand in front of the 3. Hello, how do we make painting like this? So I can randomly place many objects, but remember, these objects are gonna come from scene, right? Before I show you how to do it using Tilemaps, I need to show you something very interesting. Notice that normally people repeat scenes for many objects using something what is called duplicating. Ctrl+D, and we've got one more tree, right? That we can move. One more tree that we can move. And this causes problem because it clutters your game tree for things that repeats itself many times. And that's why you can solve it differently. Like, for example, you can group them into a single node and call it, for example, objects, right? The first problem that we have with this solution is that we need to enable now also the ordering for the object's parent node, okay? But the second problem is that we still gonna clutter my scene when we have here like, I know, 50 trees, 10, 20 mushrooms, 20 rocks, and so on, right? This is not something that should show up here, right? This is something that we should just paint. And well, we can't now paint many at once in random places, right? And that's why we're gonna put it into different tile map layer. So we have got tile maps here, and I'm going to create tile map layer, right? And let's call it objects. And now we need to put here somehow, instead of the tile map, a scene collection. So when we create here a new tile set and we go into tile set, we need to now hit here plus button, and instead of choosing Atlas, we're gonna choose scenes collections. And now here you can drag and drop scenes. So you can just drag and drop it from the scenes folder, or hit the plus button and choose the one that you want to paint. So for example, a tree. Now when we go to the tile map and choose a tree, I can paint trees, as you can see. Sometimes even too fast. And that's why I'm gonna use the option to paint using rectangle. This is also painting them too fast. So that's why I'm going to choose the scattering option, which, as you can see, if it's low value, it's gonna make them, you know, show often. But when I put it here, for example, 100, as you can see, only 2, 3 showed up. And that way, this is cool because I can like, okay, I need to paint many trees, right? So I'm gonna just choose this and do something like that. And bam, okay, that looks good. I have trees on my map, right? And, you know, I didn't clutter anything. I can also, the cool thing is that I can now remove the single guy like that, right? Okay, I don't want this one. I'm just gonna remove this. Okay, I can remove these trees because they're on different layer, right? We don't need it anymore. But I can delete any object from here, right? Like, okay, I don't want this one, I don't want this one, right? I can remove them easily now. To make sure that they disappear, let's choose the rectangle, okay, and this, and then when I choose them, as you can see, they disappear from places where I want. So I have got more control of drawing each tree, and I keep every bonus that comes from the scene, right? We could make here them being able to be chopped by axe or something like that, right? And all of these three would have this behavior, right? And they are on different layer, but there is also one more thing that we need to remember now. Notice that when we have got the player, let's do something like that, the ordering is not working. So we need to choose now objects, and we need to make them ordering. As you can see, now they order properly with the trees itself, but not with our player. When I choose the player, as you can see, it's not working. We need to also change the ordering for the tile maps, for all tile maps. And now, as you can see, everything is working fine like in the previous lecture. Today I will show you how to make animations for the specific tile from your tile set. So for example, do you see this rock here? It's looking cool, right? Let's make this foam around the rock. Let's move rock to the asset folder. And now we're gonna attach it to the object tile map tile set, okay? So before, in the last lecture, we created what? A scene as a tree. And we could paint it as a different object. And this solution is needed when you want to apply something later, for example, chopping, right? You want to be able to chop this tree, so you want to interact with it. But in case of rocks that you are not going to interact, you do not need to create different scene for just rocks, right? You can just put them here inside a tile set like that, right? And I'm not gonna use the automatic creation for Atlas this time, because by the default, as you can see, the texture region is set to 16 by 16, which is just too small for the tile set we are using. So let's change it to 128 to 128. And as you can see, now we have got big squares that allows you to choose specific position here. And now it's very important. We do not choose all tiles. we just choose the first tile, the starting position of our animation. Then we go into the select mode, we choose this tile, and here you have got a animation, and you need to now say how many columns our animation is gonna be animated from, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? So we have 8 columns, and now we need to attach each frame. How do we do it? We go into frames, and here when I add element, as you can see, we added the element one after another, as you can see. Okay, one more. And now we can paint them, but before you close it, you need to know one more thing, so do not close this lecture. Notice that when I paint it, the animation is very slow. But why? Notice that the duration for each frame is 1 second. I could manually change each of that frame to something smaller, but what if I decide to change, it again because I didn't like it? So I'm gonna change it 8 times then? No, that's too slow. That's why you can specify the speed. So right now it's like 1 divided by 1, which is 1. If you put here 2, it's like 1 divided by 2, so it's 0.5 seconds, right? And if we type here, for example, 10, as you can see, the animation is now fluid because it is just 1.10 seconds for each frame, right? And that's looking good right now. And yeah, that's it. We can now paint easily rocks, and we can, look at them, how beautiful they are. In this lecture, you're gonna learn lots of very interesting stuff, like, for example, signals like creating area that we detect our player and it will make him die. So very fun, right? Dying is fun, especially in games, because without the feature like dying, the game is just, boring, right? Okay, so how do we do such things that when enemy is coming on to this guy, I want the player to die, right? I want to do like something like that when there is gonna be a zone here, an area around the goblin, and this area is like close to our player, I want the player to die. And to be honest, I would like to also make this area like this, so when it's on, for example, a trap or on another enemy that is bigger or smaller, to work properly too, right? Not only in situation like, for example, here. So to make it a universal solution that will work always, right? We need to create something what is called, for example, kill zone, kill area, right? It's gonna be an area that's gonna detect when the player comes onto something that is gonna kill him. We're gonna start from creating a scene, and we're not gonna choose 2D scene as the base of our root node, but we're gonna choose other node and find here something what is called area 2D. As you can see, area 2D is a space that detects other collision object 2Ds entering or exiting it. Okay, so this is a place that's gonna just detect things. Okay, area, a zone for detecting. I'm gonna change the name of it to kill zone because this area is also gonna kill things. And now we need to specify how big this area is. And we specify it, as you can see, we have exclamation mark here using collision shape 2D or collision polygon 2D. So Ctrl+A, let's choose collision shape 2D and hit create. And now we need to specify like a default shape that is gonna be attached to any kill zone that we attach to it. And to be honest, I will do something like that, for example, but you can change it later, don't worry. I will show how, and to be honest, most people do not know how to change it, even though we have specified something like that here. That's pretty fun. So we have kill zone with a default collision shape 2D. And now remember that this collision, this is very important. This is not something that is going to collide with player, like it's gonna push it, right? Because the kill zone is area 2D. It is not a static body 2D that you can't pass through, for example, right? It is just area, okay? So this is only area. Remember, zone. And we can now attach it to enemy. How to do it? We choose the enemy scene and hit this thing here, or Ctrl+Shift+A, and let's find kill zone. As you can see, we have got it here now, but it looks the same as collision shape, and to be honest, I really don't like it. So when I go to the kill zone, I can change the color of it, okay? How to change color of it? You can go to canvas item, visibility, and here you can change, for example, it to something like that. The most important thing for me is that now when I choose any scene, I can see that, okay, this is kill zone, right? And this is the default collision shape of that enemy. And this part only is gonna kill the player. So we attach it here, but remember, we can attach kill zone to any type of enemy right now. We can attach it also to traps, and then we can change the shape of it, but how? Almost nobody knows that you can click here and now hit on editable children. And then when you choose the collision shape, you can change it to the specific problem you are having, right? So this is just a default kill zone here, okay? This is a default one, but you can easily now do even a different shape, right? You can say, hey, yeah, I want to use rectangle in this situation. And this is gonna still keep working. As you can see here, we have a default one in the kill zone, but here we change it to the rectangle, and it's okay. So you can make it like, you know, different. It's up to you, right? You can use the default option if you want, right? But you don't need to, okay? So it really depends on the situation you have. In our case, well, we can delete it and use the default one, but just take in mind that yes, you can do it this way, right? Okay, so we have a kill zone that by default is like that. Let's make it a bit bigger by default. Let's detect a player that's gonna go into the kill zone. So when we play our game, we want like, hey, this guy went into him. And to be honest, to make it easier to spot, let's do it this way. So as you can see, this is the time when this circle goes into this circle. I want to detect this situation. How do we do such things in Godot? When we go to the kill zone and choose the area 2D, we have something like here, a tab that is called node, and here we have something what is called signals. The different name for this could be events. So when an event happens, we want to signal, which means inform about that it happened. So when something enters this, so when any body enters it, and one of the body can be what? Our player, for example, right? Then I want to be informed. And when I double click it, connect, as you can see, we do not have script that we can connect it to. It's because we didn't attach any script to kill zone. So first, let's create a script. Let's put it into scripts folder. And now when we go to kill zone again and go to node and choose the body entered and then connect, as you can see, we connected this. Now when I click here, I will always open this part of code. As you can see now, when I go, for example, to kill zone, right, this, I will open this here, right? I can even, for example, close it, right? I close it totally. So let's find it. This was kill zone, right? And now when I, let's say that I am player, right? And I hit this, as you can see, I open this instantly, right? And this is the place where we need to put a code that will like do stuff when body enters the kill zone. So let's remove this part here, the pass, which means that it just doesn't have any code right now. And let's print here. So let's print here on the output that it happened. So for example, you entered me. And now when we run our program, look here in the output. As you can see, we have 2 times you entered me, even though I have not entered them. Why? Because, well, they entered different bodies. Like, for example, tree. Notice that when they come near the tree, as you can see, we have entered here. And when I come into them, enter them, as you can see, it happens. And also it happens only once, which is good. But it shouldn't happen to other things. It should only affect who? Our player. And this is pretty hard to solve problem. How do we do this? How do we detect only player? Notice that we have got here something what is called on body entered. Body means that, look, player right now, when we try to change the type of it, it is character body. So it is detected. When you go to tree, notice that the type of this guy is what? A static body 2D. So it is also detected. But we want to attach, like, you know, invoke this only when it enters the player. We could make here conditional statements that would, you know, check only for the player, but still executing any code just because, you know, on every possible body, and there will be many bodies in our game, is just lose of the computer time, right? We should detect only something that is on the player layers. But what did I say now? Look, now it is probably one of the most important things you're gonna learn in Godot, okay? When I go to the kill zone, notice that we have got here something like collision. And here we have layer and mask. Layer means where my kill zone is. Mask means what do I detect. So, our layer is now currently on layer 1, which is default layer. Everything is there. So let's go to the player for a second. Let's go into collision and let's say, hey, I want to be only on layer 2. So it's different now. And also I will hit here on 3 dots and let's add it here. And let's say that it is the layer 2 is player. This is important because now when I move my mouse over here, I will have a hint. Okay, so this guy is on player layer and only player is on layer 2. Okay, and when I go back to kill zone is on layer 1, but right now it detects everything that is on layer 1. Our player is not there. So let's do something like that and let's hit number 2 because on layer 2 is our player. And now we're gonna detect only player using kill zone, nothing else. And this solution is good because now we don't need to make any conditional statements here. So we don't need to make here like if this is not a player, then blah, 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 blah. No, hey, this is gonna only detect things on layer 2 and only player is there, right? So now as you can see, we do not see anything here on output, but when the player like enters this guy, well, this happened, right? And now we can decide what should exactly happen here, right? So for example, let's kill the player, right? And the player, the body that entered the kill zone is really inside this body variable here. So I could do something like that, body, and I can access now anything from our player. So when I hit that, I can do something like Q3, which means free remove the body from the game. Let's play the game. As you can see, now it doesn't detect anything, right? And it doesn't kill our tree, for example. So everything is okay. But when I go into this area, as you can see, I died, but also we've got an error. And why is that so? Because when we remove the body, it doesn't mean that our game stopped working. This thing is just freeing, which means it removes body from the game, right? And that body is our player. But we still have, for example, in enemy, GDScript, things that work, like code that is working on the player, right? But it doesn't exist. You can't work on something that doesn't exist. That's why we had an error, right? And that's why we should do something like that. instance valid. So it means if the player exists, then, and I will just put all these things like that. So only if the player exists, then do all this stuff here. Otherwise, don't do them. As you can see, it removed us from the game, and well, you know, nothing is happening because we are just not anymore here. Camera can't find us, so it's bugged. We should show here, for example, game over and let the game reset, maybe make it a bit red or something like that. It's up to us what we're gonna do now, but we did what we wanted, right? We just killed the player. Our game is starting to be fun, right? You have probably noticed that we wrote some code in this lecture. Normally, we used AI. I did it, and also I showed you how signals work and so on, because you need to understand the process that happens behind the scenes. Otherwise, you will not know what to ask for, and well, you will not know where to click onto, even if AI helps you. But notice that I asked, create a kill zone scene that I can attach to places where the player will die immediately, and I showed example between these things. So it knows that it is example. So after attaching a kill zone to an enemy, when the player encounters this space, it will cause the player to die. And I asked it, how could I code it, right? And only focus on dying part. So as you can see, it did the same. Node to D as the root. Well, it can be root node to D, or it can be area to D. It depends on how you want to, you know, put things up. Then the collision. Then we have got the script, right? For collision detection. And we use the body enter signal, but it connected the signal inside the code. Why? Because hey, it doesn't have ways to, you know, edit things in your editor like we did, for example, in Killzone. We added signal from here, but you can do it also manually using code, okay? But this thing is a bit better because you can, you know, easily see which signals are used from within your editor instantly and jump to them, right? So I like this approach more, but you could ask it to, you know, how to attach this signal using, for example, editor. And as you can see, it checked if the player is in the group, because the solution that I showed you, for example, here, so I put the player on another layer, is one of the solutions that you can use. And I think it's better in this situation because you don't need to make conditions later here that's gonna be executed, right? AI took approach like this. It went into the player and put it here into something what is called a group. And then if you attach it as a group, so if you hit here plus and type here player group, for example, right? Then you can check if something is in this group and then make it die, okay? So this is also a good solution, but I prefer my solution in this situation. As you can see, it also made the player die from another place, like it created function that makes the player die. And this is very good idea because, well, you can put additional logic, which means additional code for player death, like game overs, sound effects that we're gonna talk about in next lecture, right? And as you can see, it really did everything, and it said how to do things that I showed you in this lecture. So the conclusion is that, yes, you can use AI to learn coding, because remember that I could now ask for each specific place here and do something like, could you explain this part as if I was 10 years old? And the explanation is gonna be amazing, right? AI is great for that, but without video tutorial like I did now, it's also very hard to, you know, ask for something AI because you don't know where to click things, right? And there are some features that are not shown by AI by default. Like, for example, you don't know how to change the collision shape to D from within the enemy, or for example, trap. You need to know that you need to hit editable children here. So in this lecture, you learned that area to D is what? It is a place that can detect, it is a zone area that can signal, inform using signals what happened to this area. Like, for example, oh, body entered it. Oh, here is body exited, right? So you could also detect if something exited this area, right? So it means that you can use it not for only killing zone. You can use it, for example, for like tooltips. So when the player comes near some kind of, sign, right? And when he comes near it, you want to show up hint for him. When he body exited, right? When he exits this place, you want to show, for example, nothing. So you want to make it disappear. And this is powerful, right? When you understand the process behind, you can think of solutions, right? You can then check, for example, if AI had another idea for the solution like that, or you could write the code for the specific part that you don't know exactly where to look for. This is powerful and very helpful. I hope you see it. And as always, if you have any questions, feel free to ask. I am always happy to help. I love reading everything that you say. Hello, my friend. In this lecture, I will show you how to make game over screen. So when you die, there will be a message like that. That message is also gonna pause your game. So you learn how to pause your game, how to restart it, and also how to use project auto-loading feature. And what is that? How to use it, why to use it, and so on. Let's go. How do we create user interface like game over or button in Godot? In order to do it, we hit Ctrl+A, and here notice that we have got something like control, which is green. And any node that is used for something what is called GUI, which is graphical user interface, so for the things that you show to the user and it is graphic, is stored in this node. It is the same as for Node 2D. Notice that we learned how to use, for example, animated sprite 2D. We use the collision object 2D, area 2D, right? We learned about a few things from this node, and all these things are stored in this Node 2D. In control, we have things regarding the user interface, okay? And when I create it, I can now, for example, call it game over, okay? And I can put inside of it now things that will be related to the user interface. Like, for example, label, which is inside a control, as you can see. And now I can, for example, type here game over, okay, and save it. But where is that game over? Okay, this is in the, like, our initial position of our game, which is 0, 0. This is not what we want, right? We want it to be like in the middle. Like, I don't know, but where is middle of our game? That's a good question, right? So when I open this game, notice that game over, okay, we died. That game over is like standing here. And it's not moving with us, right? It's not following us. So this is definitely not what we want. So we're gonna change the type of game over and do it like this and change it to something what is called canvas layer. For things that you want to show up independently, so it means that it doesn't matter where you put these things in your game, right? You just want to show it like on top of other things, on top of your game. You need to use canvas layer as the parent, okay? Also, I made again this mistake here. Game over. I'm sorry, I have ADHD and I'm without my medications today. So game over should be here. And now we've got here what? Label. And now when we play it, as you can see, this label is like, on top of us. And that's good. I like to have things on top of me. So when you have label here, notice that now we can move it, but this is still not good because, well, it would be great if it was in the middle. And to be honest, looking at this, it's hard to spot where everything is. That's why we're gonna hit this here and change this into the scene. Save branch as scene and save it into the scenes folder, okay, like this. And now when we open it here, it's easier to see the viewport, so the size of our game, which is set where. When we go here, it is this size currently, right? We can clearly say, okay, that's here, okay, I can see it now. And now we can put it in the middle. It's easier to do. We can use things like, for example, that it will always be in the middle. But to do such stuff, I will need to go deeply into the user interface things, and this is not the topic of this lecture. It would take a bit too much time. So for now, I will just set this here, and I will show you how to, for example, change the size of game over. When you go here into the control, you have theme overrides, font size, and you can change this to, for example, 120 and set the size to game over. Now we're gonna use something what is called button, and button is just the thing that you can click, and I'm gonna type here reset button, and I'm gonna put it here, and also change the font size to, for example, 60, right? So we have a reset button in the middle. Now when we go to here, as you can see, it's probably in the middle. The most important thing is that it's following us. We can click on it, nothing happens, it's okay. But well, we probably do not want to show up game over instantly. That's the first thing. And the second thing, that it would be great if there was some kind of overlay. Let's do it then. There is something what is called color rectangle, and when you put a color rectangle, you can change the size of it, not manually, but here when you hit this, you can change it to the size of your viewport, okay? And you can change the color of it to, for example, red. And as you can see, now we have red panel here, which is a bit too much, I think. But the thing that I wanted to show you is that when I hit on this, you have got here something like transparency. So you can change this to, for example, I want it to be like 25% transparent. Here it looks like it's a solid color because, well, behind we have a solid color too. But here, as you can see, it looks better, right? And now when we are here, we have got like a reddish color on when somebody dies, right? So when I do it like this, as you can see, you can change the visibility here. It's not gonna be shown at the start. And now I want to like show it when I hit the kill zone, right? So how do we show it? When we go to the kill zone, and we go to the script of kill zone, here we kill the person and we also want to show the game over. But how do we access game over from this particular place? There are many ways to access node like game over, but in this situation I think the game over user interface should be always available. And normally we would do it through something what is called game manager, but I do not want to make this lecture too complicated because I always say do things step by step and learn from your mistakes. So I'm gonna hit the project here, project settings, and go into something what is globals. And here I can choose the scene that I want to add as a global scene. When I open it, and I hit add button, now I can access it in my code whenever I want using this name here, okay? So game over. Now when I close it, this is gonna be fun because when I open it, you will notice that we have got visible game over, even though I have got hit here and invisible. It's because, well, I can even delete it. Why is that so? Because anything that is added here into the globals is gonna be auto-loaded. It means it's gonna be attached to the main tree of our game, right? To this thing here. So it is gonna be added. As you can see, it's visible, it is there. And now if I want to by default make it invisible, we need to go to the game over, then go into the layer and change this from on to off. So this is now a default state. As you can see, it's invisible, or you could do it from here, right? This is the other way. Okay, so now it's invisible. Let's start, and we want to show it, right? So when the player dies, I want to access game over, and then yeah, I want to show it. But how do we show it? And as you can see, you can use AI to ask how to show hide something. Is there a function that does it? Because as you can see, yeah, there is also a function. You can change it not only using the property like true, false, but you can also use the hide and show functions. So I can do something like, hey, show it up, okay? And now only after I die it shows up. And as you can see, this is also cool that it changes our color a bit to reddish, right? So it shows up like, okay, you just died. So we know now how to show it, but we need to now also make it possible to reset our game. How do I reset game in Godot 4? Shortly, I said, because I don't want it to go deeply into this. So all I need to do is invoke something like this. I need to execute it when what? When the button is pressed, right? This button here. So when I go to the button, notice that, okay, maybe we shouldn't do it from here because this is a problem, because we don't see how it looks like, right? And this is definitely not what we want to have, because we want to be able to play with it. So this is not a good place to make something visible or not visible. And to make it like from the code, we need to attach here a script, okay? And here is a function which is called ready, and this function is run. This is a special function that is made by Godot creators, and it is run when the node enters the scene tree, so when the game is loaded with this specific thing. And then I can set, for example, I can just hide it, okay, by default, something like that. So by default it is now hidden, and we can clearly see it in here. So this is what we want to have. And now when somebody hits on a reset button and we go into the node, notice that we have got here events, signals that we talked about in the previous lecture. But because it is a new topic still, I will remind you that these are things that happen, that registers, observes when the thing, like the label here, like pressed, is gonna be emitted. So when the button is toggle.press, this signal is emitted. It means this is gonna be invoked. And when I hit on this, I can now connect it, but I'm not gonna do it now because I need to change the name to reset game button. Why? Because this is gonna be a bit more self-descriptive then, okay? And now when I connect this, as you can see, this function like now says something on reset game button pressed, and now I need to just invoke this from the AI. This is just getting the tree, so our main game tree, okay, and then it invokes reload current scene. And to the people that think like, hey, but you should do all these things on your own, you shouldn't use AI for such things, do you know what happens in get tree exactly? Do you know how it is coded? Because do you know how it's coded? The reload current scene is coded. No, you just do get the name of it and you use it. So this is working, right? This just solves the problem. And what is more, notice that looking for this using AI, even when you are using it like a documentation, it's gonna be faster than looking into documentation here, right? So how do I reload a scene? Reload, you know, when you forget some things, it's hard to find these things in documentation, because sometimes you need to look through many functions, many properties. This is just faster, right? And now when I play this game, as you can see, I can reset our game, but after resetting it, we need to also, we need to access game over and hide it, right? And now when I play the button, as you can see, everything works fine. But before we stop this lecture, I want to show you something very, very, very interesting. It's about pausing and unpausing your game. Notice that when we killed our person, we had to, in the previous lecture, also stop execution of, for example, things in enemy node. But our game can get big and there can be many interactions in our game. So instead of killing our player, we're gonna command it, Ctrl plus key commands the line of code, and it's not gonna be executed now. And here I'm gonna like pause the game. How to do it? Well, let's ask Ike how to pause, unpause the game. And notice that I could tell you this, right? But things like that, to be honest, you don't write so often, right? And you can just forget it. And I know that you can forget things because I have ADHD. So I am always like, hey, the most important thing for me is to know the process, to know how to code, okay? It's not to remember all the things. And now when I do something like that, I pause the game. But this is not the end of our story. Notice that we can't now hit the button. We paused our entire game. Okay, this is very important. We pause it entirely, including what? Game over. And to change it, when I go to the game over, we need to go into the process, and here we have got modes. And by default, this mode is called inherit, which means it's gonna be the same as the parent. So for game over, in our case, the parent is game, which is by default pausable. So it means that it can be paused. So we pause our interface too. But if we change this mode to, for example, always, our game over node, so our user interface, will always be able to be like processed, okay? But we can change it to when paused, because to be honest, we want to show the game over only when the game is paused, right? And it's also gonna work. So after reloading the current scene and hiding our, well, we need to unpause it also, right? So let's do something like that. So we're gonna now unpause our game, right? Because otherwise it will stop. And now, as you can see, we can clearly play our game, die, and reset it from the scratch. And we can now die, and we can reset our game. Game over is shown here. We did in the previous lecture, but the goal of our game is gonna be to survive as long as we can. There will be many goblins respawning, okay? We're gonna write code that will like respawn goblins in random places in future. But we need to track the time, how long the player survived, right? So he can make some kind of records, so this game have any fun feature in it. So how do we count in Godot? Firstly, let's create a canvas layer. Let's call it head-up display, which is just gonna show on top of our game information like, for example, score, the amount of HP for our player, and in our case, in this lecture, it's gonna show the timer, how long somebody survived, okay? And we're gonna choose canvas layer because it's gonna be on top of the interface that we have now. And now let's create here label. Let's call it survived time label. So it is self-descriptive, and we're gonna type here survived time, for example, 0 at start, right? And well, let's play it. As you can see, we have survived time here. Let's make it a bit bigger. So let's make it, for example, 30 pixels. And let's also go to layout and do the transform. And let's put, for example, 10 pixels on x-axis, so it's not like stuck to the left side. And we want to increase it every second. How do we increase something every second? We have got a node that is called timer. And as the name suggests, it is a countdown timer. How does it work? You have got here a property that says wait time. It means that this timer is gonna wait 1 second, and after 1 second, what will happen? It will inform anybody who is listening to the signal called timeout. And this function is gonna be executed that will, you know, listen to the timeout. So let's call it survived timer. And well, we need a script here, right? So we can, so we are able to attach it to something. And now let's attach timeout to our head-up display like this. Okay, let's test it out. Let's print here, for example, test. And when I play it, notice that there is nothing on output. Why? Because you need to like start the timer, and you can do it from code, or you can auto start it. So now As you can see, we have test 1 time, 2 times, 3 times. So the test shows up every second because timer is waiting 1 second, and then the timeout signals everybody who is listening to the timeout, and the function that listens to it is also survive time timer timeout, which invokes executes test, right? And it happens every second. If I did it one shot, it means that it's gonna happen only once, and that's all. It finished working, okay? But we want it to work forever, right? Every second. That's great. We learned something very important in this lecture, right? We know how to count. But how do we change now the value? Let's create here, for example, a variable that we'll call survived time, and let's assign to it 0 at start, okay? And here instead we're gonna print now survive time, but let's increase it before by 1. This means that we're gonna increase it from 0 to 1, and in 1 second when this invokes, it's gonna be again increased by 1 and again and again. So the value here now in the output, as you can see, is 1, 2, 3, 4, 5, and it goes up. So that's what we want, but we need to somehow update this value here. How do we access this value here? To access it, we're gonna put it like using the control here, and now we can just do something like that. This, then access text and type here survived time, right? And afterwards we can put the value like we have here 0, so we can put the survive time, which is gonna be like this. Okay, we need to also say what type is the survive time, and it is digit. Let's see how it, as you can see, it did it this way, the %d, because it means that put survive time into this place, and this is a digit. So as you can see now, it increases here 1, 2, 3, 4, 5, 6, and so on. So I ask AI how to do it, right? So I ask enter survive time into the game using the head-up display, which will represent how long the player survived before dying, and the timer is supposed to update every 1 second until player dies. And it solves it properly, but the problem with AI is that it tries to connect things like manually. It's because it doesn't know what we did using the graphical user interface, right? So it tries to do things manually, and you need to be careful when compiling things like that, because you already did it with me, for example, using graphical interface, right? So sometimes you could even ask for more specific questions, right? Not to ask for everything, but for specific questions, and it's good to understand the process behind. That's why learning to code is still important, right? Otherwise, you're gonna, for example, copy things from here that are not even needed, and it will just bloat your code. It will be just too much. Today we're gonna learn how to respawn randomly the goblins, enemies on our map in random places in random time. So the game is not gonna be like this, so we can survive forever, right? Right now we have just 2 bodies of enemies on our map, and they are not able to catch us, so our records will be of surviving just too long, right? We need to make some feature into our game that will make it fun, finally. So how do we do such stuff? Think for a second, who should spawn our enemies? Should it come from our enemy scene? Well, enemies shouldn't be able to spawn themselves, right? It should be some kind of entity that will like manage spawning. And we need to create, because of that, another node. And let's call it, for example, enemy spawner. You could add here manager, because to be honest, this is some kind of manager that will take care of spawning enemies. But let's say we'll make it short right now, enemy spawner. And now we need to think about timer. So something that will make our enemies spawn when the time for it happens, right? So let's create a node that takes care of things like that. So Ctrl+A, and let's call it timer, and let's call it, for example, spawn timer, so we exactly know what it is responsible for. And I think that we should put it as a separate scene, so save branch as scene like this, right? And now this thing also needs a script, so let's attach a script to it, and we have a base for spawning our enemies. Now, how do we spawn them? We could do it manually, think about how to invoke all this stuff, but because in this course I'm teaching you how to use AI, I will show you how to do it using Claude AI instead of doing it manually. Notice that before we are using ChatGPT, and to be honest, the context, the amount of things that we put here will make it respond with time worse and worse. Okay, it means that each response will be worse because it has to analyze so much text that we've put here. So remember, when you have a very long conversation, it's probably a time to restart it. And we're not gonna restart it in GPT, but in Claude this time. And this is super important. You never ask a question without giving a context, because otherwise AI will create so much code that will just, you will not need, you will just lose time and you will need to debug lots of things. So for our problem, I did something like that. I made a screenshot of this part here, right? You can use share AX for making screenshot very fast like this. And I pasted it here, and also I attached, when you do something like that, open in file manager, you can find the path to your project and put here all GD scripts from our project, okay? And now I said from now on you will write in GD script in Godot 4. If you don't understand something from a question, so you lack context, ask me before you answer. This is very important part that many developers, when they are, playing with AI, do not add here. It's very important because sometimes AI will just guess and do some stuff, and when it does this stuff without asking you, the result will be very bad. And then I said what I put here. It's very important to not only put files, right, a context, but like say what is there, at least basic things of that. You don't need to say everything because AI will analyze it, but hey, it's good to say that there is a tree of the main game scene and scripts used in game. Do some self-reflection. And now it did a self-reflection, right? And now I've also attached the script that I mentioned before, which is for head-up display. And I said what I want to do. I would like to create an enemy spawner by removing existing enemies and spawning them in random places every time randomly 0.2 to 1 second. And it created a code here, and this is very cool. Notice that Claude is like having artifacts. This is called artifact because you can click to open it and it doesn't blow your entire screen, right? You can just look on the right side here, right? And you can copy it, analyze it. In the same time, on the left side, you can read what this code on the right side do, right? And I would just copy it to here, and let's see if it works. As you can see, we have got first error. It's because I didn't specify where the scenes are. And here in this place, it says, I'm assuming that enemy scene is named enemy TSCN, and I didn't specify it, so I need to give the path to it. So we can do something like that. From now on, remember that scenes are in root, in folder scenes. That should be enough. I think that it should know what I mean. And well, I can just pull it. And well, let's run it, right? It updated this path that we had a problem with, right? And let's go back to our code and let's run our project. And as you can see, enemies are respawning, but they are also disappearing. It's because I made a mistake while asking her. Notice that I said something like that, by removing existing enemies. and spawning them. Well, I was thinking about enemies that are in the scene, and it is my fault for being, not direct. I didn't mean to remove existing enemies, remove this feature. I was just thinking about removing manually enemy nodes from main node. Yeah, so, I could stop this, start this from the start, but you can see that mistakes like that can happen and you can be just misunderstood, especially when you want the solution as fast as possible. And it happens to everyone because we all want to have everything as fast as possible, right? And as you can see now, they respawn properly until you see that they respawn also outside of that green tiles. And to be honest, nothing is wrong with this script. If I had written it only on my own, this would be very similar, okay? But, what is a but here? AI should always be used to solve one single problem at a time. And to be honest, when you are writing your own programs, you should do also it this way. Otherwise, it will be hard, especially if you are a beginner, to debug all the things that come out at once. So this is the first feature that we did, just simple spawning, right? Because now we need to somehow constrain it, right? And we need to think about how should I constrain it, around here. We have got ground in Tilemaps, and I think we could use it because you want them respawn only on these tiles, right? Not on water, for example. So now I can go back here and ask, you know what? I want to constrain where enemies spawn, and I want them to spawn only on ground tilemap layer that I send you screenshot of. She shouldn't apologize for that, right? Because we didn't ask for something like that. Okay, so it now did constrain in a bit. So let's see how it works. And now we'll notice one more thing that I wanted to show you, that it will not work. But why? It's because we are using now 3.3 version of, and this is beta version of Godot. So what does it mean? It means that this ground, when I hit here change type, notice that it is TileMapLayer. It is different class than Tilemap. I talked about Tilemap layers in previous lectures, right? And they work a bit differently, not only on layer part, but when we go to the Tilemap layer, when I hit F1, I can hit the search help, you will notice that the methods, so the things that allow you to operate on Tilemap layer, have a bit different names now, and some meters also changed. So AI doesn't know it, and you might think now, okay, I am stuck, or maybe I should find which method is represented by which now, right? No, you're not stuck, because you can now what? Copy this entirely, right? You can just copy all documentation. In GPT, you could just link to documentation, but Claude, right now at least, I'm sure it will change in future, but right now you can't paste to it a link. So I'm just gonna copy it and do something like that. As you can see, this is pasted here. Tilemap, change into TileMapLayer. Can you update the script? I pasted you documentation, how it looks like now. So this is fun because, to be honest, even if you are experienced programmer, sometimes finding all these details and what changed, it will just take some time, okay? Here you can, not only get a code that is gonna work in the newest version of Godot, right? Without looking at that, but you can learn very fast what changed, right? So it says, okay, so I had to change Tilemap to TileMapLayer. Now get use cells doesn't take 0. You just don't put anything. And now I kept using map local, and well, that's all, right? Okay, so let's now go back here and let's paste it into our enemy spawner and let's see if it works properly. So as you can see, they are respawning. Now the game is getting harder. We can't, attack them back yet, but it will change. But hey, now surviving is not as easy as it used to be, right? There are more and more of them. We finally died 15 seconds. The game is getting harder. As an exercise, you could try to, make them respawn faster with time. So after 10 seconds, they're gonna like respawn 10% faster. So the game is gonna get harder and harder, for example. So it's another feature of your game. And the coolest part about that, to be honest, is that all this code here is not that easy this time. Because this time you need to, use methods that you do not use frequently as a programmer. Even with experience, believe me, and I have 20 years of experience in programming, if I had went into TileMapLayer, okay, let's say that I am, a pro. So I go to the TileMapLayer, and when I need to find something that would be useful for me for solving this problem, I would look at the get methods because they are responsible for returning something useful for me, right? This is like common practice to put all the things that have data into the get method. But to find this particular method that get used cells and to think about it that it stores the cells that are used by the ground map map layer, well, it wouldn't be instant, okay? Believe me. And afterwards, I would need to also know how to change the map to local in the ground tilemap layer and put the random cell from this place. This is not something that is hard, when you are looking at this code. Especially, remember, if you don't understand it, you can now put this part of the code right to AI, as I said in the previous lectures, and ask, can you explain this part of code as if I was 10 years old? And it would explain it perfectly, okay? But, making this part on your own is gonna be pretty hard to invent. And to be honest, probably you might use this part of code only in this particular game. Why? Because you don't need to have always enemies spawn randomly and on specific type, for example, right? So maybe if you had landed on your own, you improve your brain and you will get to solve problems like that faster in future. But to be honest, tell me, but be like, fair with yourself. Even if you are using the method getUsedCells here, and when you are using the map to local, do I know what is in there? Why and how does it work? What kind of math is behind there? It's not like when I go here, I will see the math behind it, right? I don't see how it works. I don't care, to be honest. It works. It does the job. That's all that I care about. But somehow, when somebody looks at the solution like this, get random ground position, right? He's like, hey, I don't know what is happening here. I need to understand it. It was created by AI. I didn't, learn anything. But hey, when I, do it like that, right? So I can see on the name of it. Okay, so this function get random ground position. So if it was in TileMapLayer here, right? And it was just one of many methods written by Godot creators, somehow nobody would have a problem with that, right? But when this was created by AI, it's like, hey, you haven't learned anything. That's not true. You, as a programmer, should know how to instruct your computer to do the stuff that you want it to do and get the result as fast as possible, right? And you can do it using AI or doing it manually and, doing it, longer, definitely longer, believe me. Doesn't matter how much experience in programming you have. Nobody will write this code as fast as AI in this situation, okay? And this is not a bad code. It solves the problem. You can improve the flow of your game, using some kind of patterns in programming to make all these things, more universal. But this is not something that you would do as a beginner programmer, because there is something what is called beginner paralysis in programming. And it means that you are creating a code and you are like talking to yourself, oh no, this looks bad. I need to start from the scratch. I need to, rethink it and do it better like others do. And you do this paralysis coding like all the time and you never finish anything. That's not a way to learn something. You should make mistakes and learn from them. So after you finish, for example, a project like this, you can then see from your, feelings that, if I had did it differently, for example, I could maybe have it easier next time. So the next time you can like get into another game and have these mistakes in your mind and only solve these mistakes up front, okay? And in each project, you will just get better, but learn from mistakes that really happened. And this is the best way to learn, okay? Because this way you will at least finish something. Otherwise, you will just be stuck forever. You will never finish anything. You will just every time watch a tutorial on YouTube. You will every time ask people how to do stuff, and you will never finish it, okay? So even if you decide to do things manually without AI, just finish things and do not care about how you write stuff at start. I guarantee you that even if you spend additional 100 hours on your first project to make everything look perfect, it will not be. It won't, okay? It won't. There will be always something that is missing. There will be always something that you need to improve. It's never like that you have instantly your best code in the world. And in my humble opinion, using AI to learn this stuff just speeds up the process of learning from your mistakes. And I will always say, it's not like you should just put this code here and go to the next feature without thinking about this code. Okay, this is not the way. You should always use AI as a teacher too. So Control-A, Control-C, go to the, for example, new chat, paste it, and always really do something like that. Explain the code line by line, as if I was 10 years old. And then learn new stuff and be happy that each time you are better at programming. And it's not like you are now learning programming theoretically, right? It will be like you are in the process of doing something, solving a problem, and in this situation, creating a game, which is gonna be fun for you, right? And you won't be stuck like normally. You would need to spend, for example, to learn programming language, and for example, 10 hours, right? Or 20 or 30 hours on just tutorials. This is not equal to the programming skill. And after all these tutorials, when you had not written any line of code, when you jump to something like Godot, still you will not do anything properly. You have problems anyway. So, because you have got now AI, you can speed up this process in the workflow, in the place where you really are trying to achieve something. Without AI, you would have problems understanding really every syntax, for example, every bit of code. Now you can, focus each time you create a feature on specific new thing and look at it and, make it. This is like practical example of coding, right? Not like something that, you know, somebody says, okay, this is a function, this is just something that is gonna be invoked, it has got instructions, and all these instructions must be followed, and there is a name like this, and then there are parentheses, then the computer is gonna jump from this place to this, and all these things are gonna be executed here. Okay, this is cool to hear something like that, this works like that. But when you hear like 100 times about a function, about how variables works, arrays, how to create dictionaries, and how to get values from them, and then you get to the point where you need to use it practically, you are like, what? There was so many things, I don't have any connections to them, I don't remember anything, and you do not write anything. So AI, I think it is really making you go further really, really fast. Believe me, in my career, I have never taught myself so much stuff as in the last 1 year. This is the future of learning new stuff. And the result depends on you. Because you can use AI to just get solutions, right? And well, sometimes it's enough, but there are other ways to use AI that I show you in this lecture to make you improve with each code that AI generates, right? To make you a better programmer, to make you a person that knows how to process some things. And you do not need to have, in this situation, a person like a tutor, right? You don't need a tutor this time. So you don't need to pay for it. You have somebody that you can ask questions that you were afraid to ask because you thought, hey, this might be a stupid question and the guy might laugh at me. So I won't ask it. And then you have got in your head some kind of, blank space that you don't understand, and you are then using some things in your code without even, understanding it. And then when you are not understanding it, to be honest, how does it differ from using AI to solve just a problem, right? At least when you use AI, you can then ask her also to explain all these parts. And to be honest, that's a very important topic, because if you show kids that there is AI or any person, because we are lazy, we might want to use it by instinct to just solve things and do not get any value from, these parts, right? Sometimes. But if you show people that, hey, this really can be used not only to solve the problem, but also afterwards you can learn how it was solved, then you can improve. And later, when you get experience like I did, for example, you will use it, maybe not for creating entirely everything, right? But to solve some parts that it will solve faster, really getting random ground position. This, if I had done it manually, after, for example, 20 minutes, 30 minutes, I could feel accomplishment, for example, right? Okay, this thing is pretty cool because I did it manually, but I would lack 20 minutes of my life this time. And for beginner, it would take lots of longer, for example, right? This is just AI is making our future better. We can move forward faster. And remember, as I said earlier, if this method was here, right? Let's say that it was here, like one of the methods here, somehow nobody has a problem with it, right? It's like, okay, it's here. I don't care what's there. It says just get neighbor cell. Okay, it's gonna get neighbor cell, get pattern. It does that. How it does that, I don't care. It does that. Somehow everybody is fine with it. But if this was created, the solution by AI, somehow, okay, this is just bad. You didn't learn anything from it. But using somehow this method here manually is okay, right? This is totally the same. But at least now, if I have time, if I want, I can exactly ask AI how it was done line by line and learn stuff. This is powerful, beautiful. That's why we as humankind will move forward so fast in the future. You can't believe, you won't believe what will happen in 5-10 years because of that. We have just new calculator. We have new way of solving things, but with using what? We use just words here, right? It's not like I had to follow some kind of pattern to say to this AI some kind of program so it understands me. I can use any language here. I can use my language, Polish one, or you can use your languages if you are from another country. And you can, you don't need to, you know, be fluent in this even language. You don't need to be always precise. You don't need to be like, you know, a person who needs to write firstly this, then this, then this. No, AI understands your simple language, and you don't need to follow rules inside of it. It's good to provide context and do some stuff in some kind of order to get better results, okay? Like I said in previous lectures, but this is powerful because this is like an advanced calculator that can solve things very fast, right? And you don't need to learn something like how to use it with some kind of syntax, right? You don't need to, like in calculator, know where to click, right? Because advanced calculators are not simple, right? They are not like, oh, when I get to the calculator, I think here, as you can see, this is like a standard calculator, right? But there are advanced calculators, right? So you need to understand all these parts, for example, here, right? So this is super powerful, helpful, and I hope you can see after this lecture how crazy time we live in and how far we'll go if we open our mind and to this amazing tool. Have a good day, and if you have any questions, feel free to ask. Make attack in our game, but also how to respond to this attack. Like, for example, let's make an enemy die. That's a good question, right? So in order to do it, firstly, we will go into the player scene, into animated sprite 2D, and we're gonna put here a new animation and we're gonna call it attack. Now I'm gonna increase the FPS to 10, okay? And afterwards, it's very important to uncheck animation looping. Why? Because we want to attack only once when somebody hits. We do not want to loop this animation like forever when somebody clicks on our keyboard, for example, space or whatever. Afterwards, we need to add the frames from the sprite sheet. So let's go into assets and let's choose our warrior. And now we need to choose an attack. Let's say that we're gonna choose this attack, okay? There are many other types. For now, let's only use this. And now notice that when we play it, our player is attacking, right? But there is a small problem in it. What kind of problem? Well, the first thing is that we need to know when should we detect an attack. Notice that we have a sword here, but when we go to the animated sprite 2D, and here we have got something like animation, we can move frame by frame. And as you can see, to be honest, the moment that the attack should like be detected, it's like only on this particular frame, right? So we need to somehow detect this area only when the frame number 3 happens. And how to do such things? We will use something what is called area 2D, because this is just a region that detects a space where we define it. And inside of it, I'm gonna put the collision shape 2D, and I'm going to use rectangle and put it like, you know, something like that. Let's change the color to, for example, red. So we know that it is like attack area. Let's change the name also, right? And this is the place where we want to like detect our enemies only in this place, but also only in this frame. And the problem is, how do we detect only this frame, right? Firstly, let's think for a second, how do we monitor detection? When it happens? It happens when this is set on or off, okay? The thing that many people do also is, here is collision shape and they can like disable or enable the collision. This is also the way. But instead of it, we can also just make it being able to monitor or not, right? So by default, we are not monitoring anything, and it means that the area 2D is not sending any of these signals. But when we change the monitoring to true from code on frame 3, then these signals can emit, that, hey, the event happened, right? And now we can run the project and anything happens? No, of course not, because we have just, player with animation that has not been invoked by anything. So now we go to the project settings, go to the input map, and let's build a new action that we're gonna call, for example, attack. Let's add it. Let's go to the attack and let's put here, for example, space. So space is gonna invoke hit. You can put it also Xbox like I showed in the previous lectures. That's up to you. But let's say that space is going to invoke this animation. And now when we go to the player, we need to code it. In this course for coding, we use AI, right? For helping. So when we go to the code that we talked in the previous lectures, we have context from previous lecture. Remember, again, you need to put information regarding your game. Otherwise, it will not help you properly, right? AI will not know what to do. So now it has got all our script. It knows what's going on, but it doesn't know about the things that I've just done, right? So it doesn't know about this attack area, for example. So what we do, we make a screenshot like this, and then we also go to the animated sprite 2D, right? Let's copy this here, and I added attack area. This is the area that should detect when monitored enemy scene, and when it happens that enemy scene body enters area 2D, I want enemy to die, so disappear. So this is the first thing that must happen, right? So I gave it instruction when this is monitored, but when it should be monitored, AI doesn't know. So now I'm going to make another screenshot like this. And now when I put it here, I will add. I also want detection to happen only in frame number 3 from attack animation, okay? I think that's enough for now at least. So I gave it the context using images because it's easier, right? I use the ShareX program for that. So it's pretty fast to do such things. And now I'm just gonna copy the content of the player. So I will go here, go to the player, go to the script, and now copy and paste it here, right? And now it's not enough. Remember, always read. It showed us how we did it, but well, we don't need to understand it this for now. Before we check if it works or not. So to make this work, you need to do the following. It's also very important. So it said that we need to attach input. We did it before. Now we need to go into NMS scene, and this is very important and something new. Because notice that in order to detect all enemies and to be able to refer to them from any place, you can create something what is called groups. And this is a new thing in this tutorial. When I choose enemy CharacterBody to the node, when you go to the node, here you have got signals, but also groups. And this thing allows you to define groups. So things that you can access anywhere in your program. And it says that you should call it enemies, okay? So plus enemies, okay. So I have now group that is called enemies. And as you can see now, you have got here what? Something like this, that you can click and see, okay, this is in group and it's called enemies. Right, so now any enemy that we respawn using our enemy spawner from the last lecture is gonna be in this group, okay, always. And you can now ask for that place. And now it says you need to connect body enter signal, right, from the attack area to the attack area body entered. Okay, let's do it. So when we go to the from what connect body entered signal from attack area. So when we go to attack area, which is in the player attack area. And now when we go to the node and signals, here is body entered. And now we need to pick the on attack area body entered, right? Like this, and connect. Now, as you can see, we have got here green thing that says, okay, this is going to happen here, right? Now, when we play it, let's see what happens. oh, I think it destroyed a bit our code from the previous lectures. And that's bad. And it happened because it didn't connect what we did before. It only, it tried to, you know, do its own script. So let's fix it. Do not, can you like connect? Can you connect the script we had before, player GD, with the script you did? So I can just copy paste. Well, you know, when there is much code, like this situation, sometimes, unfortunately, well, it will only focus, AI will only focus on creating like the solution for the problem that you've just asked, right? And it's good idea to do it like this. So now as you can see, it didn't destroy anything. And now when I hit space, well, it doesn't work. It's because AI tried to solve the problem, but didn't take into consideration that when one animation is changing from another, that you need to, you know, work around it. And normally you would need to also do it manually and think how to do such a thing. But hey, I can now, you know, solve problems step by step. So the animation right now is not finishing, it starts. Because the next animation like idle or walk is in the way. Can you fix it? So I can always finish animation attack when attack happens. So remember that you might be thinking, okay, that I can't, you know, fix everything and think about everything. Well, that's true, but it's also like happening to me when I'm writing code. It's not, I can, you know, predict everything, and it's always a good idea to debug things, you know, one by one. As you can see, it works fine. Just a few more, you know, steps. Let's make visible collisions to see how it works. So as you can see, now when we play our game, this red thing detects what? Our goblins, right? Right now I died, but it's because the goblin spawned, the next goblin spawned totally next to me. And there is one more problem. Notice that when I'm changing direction, what? The area 2D doesn't change the direction. So, well, let's change it, right? When I flip a player, area 2D doesn't. Can you change it? So you might be now, oh, there is so much code done that I don't understand now what's going on here, for example, right? But remember, as I said, now I can just do something like that. Control-A, Control-C, meanwhile, when it's being done, put it like here and do something like that. Can you explain me above code, step by line by line, as if I was 10 years old beginner in Godot, right? And let's go. Meanwhile, I can go here, copy the new code, put it here, right? And now, as you can see, hey, it works fine, properly, right? When I flip, it also flips. Let's see if it kills also. So, I didn't hit the proper button, sorry. So space, space. And now our game is getting better, right? Because we can fight back finally, not like, you know, before. Right? So that's pretty cool. We can fight back. It doesn't have sound yet, but we can also, of course, improve it. The enemies are just now disappearing. They don't have animation of dying. All that things can be changed. Easy, right? And now when I do it, go to the ChatGPT, for example, notice the explanations here. So this line means our code is for character that moves around in a 2D game. Okay. This is how fast. Okay. These are things from the previous lectures. So maybe let's go here. It makes the character play the idle animation. It turns off the attack area at start. And this is very important. So it did what I said before. Notice that we have here monitoring, right? And I disabled it manually, right? But well, AI didn't know that, and it made sure, she made sure that monitoring is gonna be set to false when the game loads the attack area. And well, I think this is a good idea to have it here, just in case that somebody unclicked this here, for example, and forgets. So this is a good idea to put it here. And now, if the character is not on the floor, it makes the character to fall down using gravity, right? And now, if you press the jump button, usually the space bar, and the character is on the floor, it makes the character to jump. So to be honest, this is the leftover from the script from the beginning of our game. We don't have floor right now, so to be honest, we could just remove this part so it doesn't take, the AI doesn't need to create as much code as it does now. We don't use it, right? We don't have gravity right now, so to be honest, we could just delete this part and this part because this is just leftover of the from the previous lectures. But as you can see, we can learn with AI, right? It's not like this is finished. So now we can see that physics process is run all the time, and if the character is not on the floor, okay, this is sorry, we read about it already. Now direction checks which direction you are pressing, right, left, up, or down. So this is the thing that takes into consideration if you are clicking right, left, down, or move up key. And it doesn't matter, also remember, what kind of key you are using. I mean, if it's from Xbox, if it is from the keyboard, right? Because we set the move left here, how it should be represented. And then the direction is checked which direction you are pressing. And if you are pressing a direction, it moves the character in that direction, right? If the character is not attacking, it plays the walking animation. So this is the part that was very important and we didn't have it before, right? That's why our player, when I tried to attack, he was still moving, right? But now, if attacking is set to true, then other animation has like the main priority, right? This walk animation is gonna be played only when is attacking is not playing. That's cool, right? And it flips the character sprite if moving left to or right? So it does all this stuff. You can just read it and you can get the idea on how to do it. It could be me that would explain to you that all those things. But to be honest, who cares who explains it to you when the most important thing is that this explanation must be good enough for you. And the coolest part about AI is that even if I don't still understand this part, right, I can just copy this and could you explain it on another example? Why don't understand this part? I don't understand signals. Can you explain them using 10 different words? That's powerful, right? But still you need to use tutorials, especially for working with editors, like where to click. Okay, so groups are here, right? Okay, and to get know how to get the process of doing all these stuff. Later, really, almost everything can be generated by AI. And some people might be against it, but to be honest, somehow visual scripting, where you just say what to be done next, is really very similar, isn't it? You wouldn't do like in visual scripting something like that, that you would get the input, get action strength and all that things into one variable. You just have direction that you will refer to and you will just play with it, right? Okay, so if this guy is going left, I'm gonna use this animation, that's all. I wouldn't need to write the code, I would just connect some blocks to each other and it would just happen. So don't worry, use AI, but also in the same time, try to look at the solution and later learn what happens in each line of code to learn new things. So when something can't be fixed by AI or you have some idea that is, very big, you can make some kind of structure on your own, right? And remember, AI is solving always like one simple thing that you ask it for. So for example, now, as you can see, we free the body that entered the attack area here, right? But should we kill enemies from the attack area? No, we should probably make a function here and put this here, because maybe I would like to also not only dispose of the body of enemy, but also I would like to make an animation, make some kind of sound, and I would also like to maybe some enemies would have more HP. So if I had to put everything here in one place, this would be a bad idea. But AI right now doesn't know that you want to do all this stuff, so it put it just here because this is just a simple, fast solution to this problem, right? And to be honest, this is enough if we had finished, for example, playing our game and this would be the end, right? We solved the problem. Why like overcomplicate some things? But some games are gonna be bigger, and because they gonna get bigger, you need to sometimes plan ahead. You can then plan ahead with AI, but without writing instantly this code. But you can make some kind of objectives, make some kind of document for your entire game, then analyze it with AI so she can help you, right? Or you can, because you learned from mistakes when making a small game, make some things on your own also, right? Because remember, the worst thing in programming is the paralysis from being like, wow, I need to make everything perfectly in the first instance. It's never gonna happen. And to be honest, I have 20 years of experience. I still make mistakes, right? And they are sometimes so funny that I'm like, really? I was doing it for such long time and I keep doing these things? Well, I have a ADHD, so I make mistakes even if I know something perfectly always. But that's me, right? That's gonna happen to me always. Maybe this is also a cause. But we make mistakes and we learn from them better than doing something like that. You need to have everything perfectly done from scratch. It's just impossible to do it on the first go. Just do your first 10 mini games and learn from each mistake. So next time, the structure of your folders, the structure of your nodes, the functions that you use, everything is gonna be each time a bit better, because you will notice, oh my God, this thing is just making me having to rewrite everything from scratch, right? The thing that I did here. I need to now repeat myself so many times. Maybe I could do it differently, but now I need to rewrite my entire code. So in the next game, you can think about these mistakes, and also you can in advance do some things on your own, or you can in advance say AI to avoid, for example, doing such things, right? You can write it down, all your mistakes, write them down and just learn from them. That's the best way. And our game currently allows us to hit our enemies, right, and kill them. But to be honest, the game without sound is just boring, especially without sound effects. How do we add sound effects? Like, for example, when the player hits something. So when you go to the player scene, we can attach to the player something what is called audio stream player 2D. And when you create this node and go into inspector, you will notice here you can put a file to play. And the problem is, if you don't know how to create audio, but because we have now AI, wow, this will be super simple. Notice that when you go to that site, I will link the site in the description. It gives you the free tier where you can play with it. You can, for example, put retro video game power up. That's great. That's really good, right? So, for example, retro video game hit with sword. And here in settings, it's very important to put how long this hit should be, okay? Because normally it's gonna be automatic and it can be 3-4 seconds, and then you need to trim it, you need to edit it. So I think it's good to play this part here, right? And now when you hit the generate button, let's see what will happen. So when I play it, okay, this sounds pretty okay. So let's download it. Okay, it's of course up to you what sounds okay or not, right? So we need to now go to our file system, create in the assets, for example, a new folder, and let's call it sounds, right? And for example, here we're gonna create another folder for sound effects, right? And into the sound effects, we're gonna put the thing that we've just generated, right? So I've put it from the downloads folder, and let's call it, for example, sword hit sound, something like this. Now let's call this also sword hit sound, and let's put this here into the stream. And now we need to just play it in the proper moment, right? So when we go to the player script, we need to find a place when we should play it, right? So I think we should played when the attack is being performed, right? So let's put it just here. How do we access this sword hit sound? We can do something like that. When I hold it, use the control, and as you can see, we created a variable that now we can access anywhere in our script. And now let's do sword hit sound, and let's just play it with the play method. And when I run this, now as you can see, we have a sound that is just adding the spice to our game. And you can create a sound when we are dying, when an enemy is dying, play with it, have fun, right? The game is gonna get better with sound. Without sound, games are just bad. But the way that we've just attached the sound is not the best way, because we don't have precision that is needed to make it, good every time. And to solve this problem, most time you put something like sound on something what is called animation player. Hello my friend, the game without music is just horrible. You are not gonna have a good game without a background like this, for example. Because we have a medieval game like this, I think this is gonna just be perfect for it, okay? So in order to attach a music, like for example this from the free sources, you can see it is royalty free music tracks. You can just click here to download it, okay? And then you create, for example, a new folder in the assets folder, musics, and you need to just put it here, right? So I am gonna move it from my folder. Wait a second, as you can see, it's now here, and you can now double click it. As you can see, now you can play it from here, right? But this is just manually playing. How do we play it in our game? You can create a node that is called audio stream play layer, or you can just move this music here up, okay, to the game node like this. And now, as you can see, it added it as an audio stream player. We can call it now, for example, medieval background music. And if I want to autoplay it, I hit on here. As you can see now, it's playing, but it's definitely too loud. How do we decrease the loudness? As you can see here, we can decrease it. And after playing it, as you can see, okay, this is good, but there is a problem. Notice that each time when I die, what happens? The music is starting from the start. And also notice that when the game is paused, our music also paused. How do we change both of these things? Firstly, if you want to pause the game and still process the music, you need to hit here process, and notice that here is a mode that by default is set to inherit, which means that it's gonna inherit the mode from the node parent. The parent is in our case the game, so it is gonna also inherit what is root and so on, but in our case it means that default option most time is that it's pausable, okay? So we need to change it to always in order to make it like always running even if the game is stopped. So now when I play it and I die, notice that it's still playing, but there's another problem, as you can see. What? The music is starting from start, and this is not a good thing. In order to change it, we need to make this music as another scene. Right click, then we're gonna make it as a scene, save it in the scenes, save, and now we can delete it. But if we delete it, notice the problem is that it's not gonna be run, right? Because it is not in our game. So we need to go into project settings, into the globals. Now we need to find our scene, which is this one, add, and now we can close. And notice that when we open our scene, here we have autoplay, and because this scene is auto-loaded in our project, when the project when our game is loaded, then as you can see the music is spreading properly. But the cool thing is that when we die, the game is still running, right? I mean the music is still running, and we can change, for example, the sound here to lower. But this is very, very, very important. This is not the way that you should decrease the decibels, the volume of your sound. Why? Because every player might want to have it differently, and that's why you should have inside of your game something what is called audio mixer, which allows you to add something what is called buses. Bus is like a channel for the kind of sounds you want to change properties of individually. So it means that you can put here, for example, sound effects, musics, for example, dialogues, right? And this allows to change each of that type channel bus individually, right? So now when I choose medieval background music, I can change it to the musics, right? When I go to the sword hit sound, which is in our enemy as far as it's in our player, like this, I can change it to sound effects. And because of that, now I can do something like, hey, I want music to be lower, only music, right? And because of that, we lowered our music. This is the default, for example, setting, like for example, -5, maybe you want it to be 0, right? But I can change it now from this place, but this bus can be, accessed by your game later, and you can within the code create an interface that allows you to change all these parts individually, right? So this is very important, remember. Why? Because, for example, I have ADHD, and when the music is very high and I can't change it, okay, to be or mute it if I don't like it, I won't play this game because I can't focus, okay, when the music is loud. That's just how am I. One of the most important things for your game is to be able to customize the level of your sound for each of that thing manually. Master means that you can decrease all at once, right? This will decrease sound effects, music, and dialogues by this value here. So when I open it, as you can see, our music got also a bit more silent, right? But if you want to move it individually, you can just use these parts now, right? So most time people like me, for example, want to have dialogues higher and music lower. That way I can, easily spot dialogues in the music, and I still have fun while playing. For example, it's me, right? Everybody is different, and that's why customization like that is super, super important. Notice that this is not the only site where you can find free music. Another one is, for example, Open Game Art, where if you type background and then you choose music and CC0, also you're gonna find cool music that you can download later. There is also music on itch.io, which you can also download if you set the CC0, and also the freepd.com, where you have the music categorized by type, right? Because sometimes you want to have some upbeat, the positive, something dramatic, horror, you can play, download. This is super cool that where you can, without knowing anything about sounds, do some things like that. There are also AI tools that allows you to generate music, but most of them are paid ones, so I didn't show them here. When you're creating a game or programming anything, to be honest, you are gonna make mistakes. Something is gonna go wrong. And when you change many things at once in many places in code and the game is not working, you are like, how am I gonna go back to the place where everything is working properly? You're gonna lose lots of your time like this many times. Your files might get corrupted. You might lose your files. Everything can happen, right? So that's why you need to have something what is called a system control version, which is not only for that, you can also collaborate with others when you are using something like that. But in this tutorial, I will just show you the basics, so you will not understand after this tutorial what is commit, what is branch, how to discard changes, and how to push changes to your repository, and what is repository, and so on. So this thing is like a solution that is gonna allow you to make like checkpoints, which are called commits, at each stage of your work, okay? So you have some kind of safe copies of your game, and you can track all the changes you make. As you can see here, you can see that somebody changed in this files, he added this and this, right? This green suggests that it was added. You can just track what was changed, and then you can accept it, which means commit, or you can just discard, which means you just don't accept it. So it's like having an undo button for your entire project. So your project is like being followed by an external program, and you can experiment without fear. So this is very, very powerful, and it's gonna save you lots of time if you start using it now. So how do we do that? Firstly, you need to go to the github.com, you need to sign up. So register, then go to the GitHub desktop and download the GitHub desktop. It's gonna make your journey into Git easier. Many people use terminal. I don't recommend it because, well, most time interface is just enough. Okay, so after you download it, when you create a project in Git, in Godot, and then when you open your GitHub desktop, it's gonna ask you about where is your repository. What is repository? Repository is just, you know, the code base. It's like a project. It's just your project of your game, okay? Everything that is connected to your project is called repository. And where is it, right? So here is our game. Now, when I hit here, right click, open file in manager, you can then like drag this into where? Into here. So like this. And now, as you can see, it says this directory doesn't appear to be a Git repository. Would you like to create a repository here instead? Because normally, if not this program, you would need to initialize this as a repository. Okay, but because we have this program, we do not need to worry about it now, and we can just click on create a repository. We don't need to do it from terminal, from the console. So now here is the name of your repository that is gonna be, you know, name of your project, right? Let's just call it new game project. Is up to you, right? You should just put here the name of your game, for example, and description. What is this project about? Then here is something what is called README. README is a file where you can put things like information, how to use your project, what is this project about, and so on, right? It's a good idea to create this file later. You can just, you know, edit it or not. It's up to you. Then you have got something what is called git ignore, which means what is gonna be ignored, and we're gonna choose a Godot template, because you see, git ignore is a file that allows you to ignore things that you don't want to upload online. Because you see, GitHub is a hub, so it is a place of all the repositories that people use. You can have their private projects that nobody will see, right? But you have ability to create public projects, and to public projects, well, you don't want to upload things that should be secure, like for example your keys to APIs or some passwords, okay? So this thing is like a template what shouldn't be uploaded regarding Godot project, okay? So it's like base, you don't need to even think about it right now, you're just gonna do it. If you are writing in something else, you just choose the language that you are using here, and it's gonna make a template for basic things that should be ignored. Then you have a license that you want to upload your game to repository to. Let's choose none and create repository. And now what happened? We created on local place on our PC a repository, so something that is gonna be observed. What does it mean? It is now observed by our Git system control version. It means that whatever I do here now, right? And to be honest, whatever I do in this folder that is observed, right? Is gonna be shown here. Okay. So let's create 2D node, let's call it game. And let's save it. And let's go here. Oh, as you can see, yes, there was a change in our project. We created a scene. And here is what was changed here. Okay, so let's say that we want to attach a script now here. And let's just create and save. Okay, so as you can see, there is a new file now, a script that is called GameGD. And here are new things that were added in this particular like checkpoint. Because notice that whatever I add now, let's say that I add here now, for example, print. As you can see, print test showed up here too. It's also green. Why is it important? Because let's say that we are ready. Let's say that this is like base of our game. So base of game created. Okay, let's say that this is just this and I commit it. It means that I am committed. I'm sure that I accept all the things that were done here. And I'm ready to say, I think they are good. It doesn't mean that I can go back, okay? But hey, I just accepted this. And when I go to history, I can see what was accepted and when was it accepted. So the initial thing was when we created our project, right? So as you can see, we created our project, which is project.godot file. And we have our icon, right? This is the base, the readme file where you can describe your project, the git ignore that I talked to you about, right? So these are the things that are gonna be like ignored. So for example, as you can see, the some configuration files, for example, are not needed when you are publishing things. So these are the changes that were made. And now I can, let's say that this is the end of the day. Let's publish it to the GitHub, the place, the hub, the center for the Git repositories, right? Let's publish it. And you can keep this code private. At start, always keep things private because you don't need to show the things that, you know, you are just experimenting with. But if you want to, make it public, you can just uncheck it. You can uncheck it later also, so don't worry. And you can then publish it, right? Wait a second. And then now when I hit view on GitHub, if you are logged in on your account, you will see what your project, okay? And if you are not logged in, so when we are, for example, in incognito mode, as you can see, we can't find it, okay? So yes, this is just for you. It is like a backup, the online backup of your game with history, right? And as you can see, here we have name of each commit. So each thing we like accepted while writing the code. Initial commit is the commit that is here, right? And the base of game created is here. If there were more, you would see which folder was updated when, as you can see, it says 3 minutes ago, 20 minutes ago. You can also see a date when you move the mouse over it. And here is a README, right? So it means this is the place where you can describe things. So when I go to README and I put here like description of my project, then it will show up here, right? New game project is that thing that showed up here. And this is not public. This is just for you right now. But you still, I think, should do it because it is like the place where you finish your day when creating a game, for example. Even if you are not gonna collaborate with others, this is a good idea, okay? So when we are in our, for example, game now, let's say that I've implemented something. Let's create a player, right? So let's create CharacterBody 2D. Let's save this as player. And let's attach here a script, right? Like this. And all these changes are gonna show up here in the changes. So I created a player. I think this is pretty lots of things. So player created. Let's commit. I'm not gonna push it, okay, to the main branch. Branch, as you can see here, is called, here's something what is called main branch. Main means that this is the place where your main project is, okay? This is like main project. You can have different branches, but it's not the topic for now. Let's wait a second. But we are not gonna push it to the origin, which means to the main branch right now. No, you don't push each commit, right? Only at the end of the day, for example, or when you are totally like, okay, this is finished. But now I can clearly see what I did today, for example. Okay, so I created the base of the game, then the player was created, okay. And now let's say that I'm like, you know what? I don't want to have jumping in my game. So I deleted jump here, and let's say that I deleted gravity by mistake, right? Because I am like, I have ADHD, so I did it, you know, too much. And let's say that I'm working on my project, right? Removed velocity, for example, like this. Let's say that I'm working, something is going on. Now, right now I can use Ctrl Z, right? But when I close this, you know, Godot engine, I won't be able to use Ctrl Z, right? And when I come back, I'm like, hey, but how do I make the floor thing, right? How do I make it the gravity? Now I don't remember. Okay, so I can just go here, go to the history, and it's like, oh, this is the place where I removed it, right? For example. And let's say that, you know what? I want to go back to this place. And in order to go back, you can just undo commit. As you can see now, when I go back here, right? When I go back here, I can like say discard the changes, because I'm like, you know what? I don't want these things to be removed. So discard the changes. And when I come back here, I am informed that files have been modified on disk and what actions should be taken. I'm not keeping the local changes. I'm just discarding the things that are in Godot project right now and reloading it. And as you can see, I have my code back. All right. And you know, this is cool because when you make many changes, you can see clearly what you did in this day. This is also, you know, a good way for people with ADHD, I think, because like me, because we like results, right? And when we can like do one thing and do a commit and you know, see, okay, so I did this, I got a hit of dopamine, for example, right? So commit is like a change that you accepted and it is now in your history of local changes, right? And well, you can make commits and after the day you push it to origin. But there is one very cool, a bit advanced feature, but very worth to learn. Let's say that I want to create now attack feature in my game. And it's gonna be pretty hard, right? And I am not sure if I'm gonna keep it in my game. So what do? I am not gonna work on my main project because this is like a heaven for my project. I don't want it to be destroyed. I don't want to also, you know, have my history here weirdly placed. I want to like make something that can be removed later without any problem. So I'm gonna now create a new branch and I'm gonna call it a new attack. And let's create. And what happened? When I am here now, as you can see, it's like, nothing is happening here. But now when we make a change, let's say that I'm creating this feature here, right? So this is 100 lines of code of attacks. Now when I'm here, as you can see, it says, hey, there is a change here, but it is in the
branch that is called new attack. When I go back to the main branch, as you can see, it says, you know what? When you are changing the branch, so your word, like your project, do you want to leave this change that you made in new branch, in that new attack branch? Or do you want to bring it with me? You know what? I don't want to bring it. So switch without bringing it. And when I'm here, I'm again asked, you know what? You need to reload. As you can see, our code here was removed, right? We don't see here these 100 lines of code now. So this is not here. Where is it? It is on another branch. So to be honest, we can now work on other stuff here, right? It's like, hey, I'm gonna work now not on an attack, but I'm going to add, for example, animated sprite 2D, let's say, right? Because I need to have animations. And as you can see now here, we are informed about adding this node, but I can still be like, you know what? I want to go back to this feature. So let's go back there. And now I can bring with me this unchanged commit, this game.tscn, or leave it here. We're gonna leave it, okay? And now when I reload it, as you can see, animated sprite 2D is removed. And here we have something what is called stash. Stash are changes that we have not committed. And when I go back here, as you can see, here is our 100 lines of code. We can now restore it. And as you can see, here we have a code with our attack feature, but without animated sprite 2D. And now let's say that I am like, you know what? I want to merge these two things. So you can do it in two ways now. You can do it like this. I am changing to the branch and bring it with me, okay? Or you can leave it, okay? And do something like that. Branch, merge, but before that we need to, restore the things that we have here so we don't lose it, okay? And now branch and merge into current branch. And we say, I want to merge these things. I want to put this into this, right? So as you can see, we are not able to do it, but why? It's because when I go back there again, notice that we have got here changes that were not committed. Because here, to be honest, we also can commit on another branch. So we can be like, this was implemented attack feature, right? And as you can see, we have a history for this branch. And let's say that I want to do much more things. Like, for example, let's say that I'm gonna attach here audio stream player, right? The sound is in our game now. And when we go here, okay, so I added sound to my player or game. Okay, this is to my game, right? Because this is a game node. And now we have a history that we also can, undo, but in another branch. But when everything is finished here, right, it is committed, I accepted all the changes, I can go to main. I can now, for example, restore this thing that we did here. And I can now merge new attack into main. And now when I do something like that, as you can see, it cannot change because something was different. And I can stash and change. And now when I discard it, as you can see, we added the audio stream player, we added the attack feature, but we do not have what? We do not have this thing. I can now restore it. And as you can see, we have got here what? Conflicted. Why do we have information like this here? Because our game node now have audio stream player 2D that we got from the branch that was like different word, right, of our game. We imported it here, but also in the total the same place, we had animated sprite 2D. So this is like conflicting. We do not know if we should put animated sprite 2D first or maybe audio stream first. It doesn't know what to do. Or should we add both of them or maybe remove one of them? And now it's time for you to decide what should be kept or not. Whatever is on blue, it's gonna be kept, okay? So when I remove this thing here, right, the updated upstream, which means that, hey, this is the thing that came from the branch that we merge with, but we keep the great thing, okay, so this is okay. Now we remove this part and this part, right? And now when I commit, I'm going to commit only this blue thing, right? And bam. So now when I go here and I discard the changes, we had an alert that destroyed our project. It's because we committed these two things, we accepted them, right? But, well, it means that they are in the history of what things were accepted. So we accepted audio stream, we accepted animated sprite 2D, but these three things that we unchecked before, right? They are still inside like a text file. And we could open it, for example, inside the Visual Studio Code, and remove them manually, for example. But we can also do something like, hey, I don't want these three changes now, right? It's like, let's just discard them. And now when I go back here, and also when I check in Visual Studio Code, notice that we have got now here two nodes here, right? One next to each other. I can open the game node main, and we have now audio stream first and then the animated sprite 2D. It's because, well, there were differences that we needed to accept, right? So when you are working in different branch, you need to take into considerations that there are gonna be conflicts. And that's why it's a bit advanced topic. You can play with it because it allows you to, edit many things at once in different places and then merge things. You can also, to be honest, this is gonna help you also collaborate with other people, because the thing that you have locally, right, it's like a copy of the thing that is uploaded on the GitHub. And well, you have the original copy, for example, and the main branch here. And when you upload things, the things are gonna be like, merged instantly. But other people can make branches of your main project on the GitHub, right? And then they can update the code, and then they can like request you to merge their changes into the main project. So many people can work on one project. This is a bit advanced, maybe not needed for you now, so don't worry. The most important thing for you from this lecture would be, even if you're not gonna use the branches, right? If you're not gonna use just one branch, this is pretty enough for now. Play with it firstly, and just, create GitHub desktop, create repository, and connect it with your game project, right? And just, commit things even on the single branch. This is gonna be total improvement. Even if you don't understand the branch things, don't worry. You don't need to. Now, have fun with just simple commits on the same branch, and when something goes wrong, you can just undo things. And that's also gonna improve your life a lot, especially when something gets corrupted. Really, losing your entire project after hours of work is just horrible. It's good to have a backup like this in your local GitHub desktop, and when you finish your work, so you can just push things to your GitHub project online on the private by default. And if you want to show things to other people, you can even publish it. That's very cool. Hello, my friend. Today I will show you something very, very interesting. What's that? When I hit on this, notice that I'm in Visual Studio Code. How to connect Visual Studio Code to Godot engine, but that's not all. I will show you how to achieve something like that. Ctrl+A, Ctrl+Shift+I, and now I will type something like that. Add types to everything. So my program is faster, okay? Submit. Because, I'm not sure if you know that, but if you specify types everywhere in your program, you
will have your program run faster because Godot is written this way. Okay, so specifying types is very good idea. Also, the suggestions are gonna be better, but doing it manually sometimes is, you know, taking time and you don't like it, or maybe you have lots of code that needs to be, you know, fixed. Why not? Now I just hit this and everything works fine. So how to achieve all of that thing is gonna be shown in this lecture. So the first thing we need to do is connect Godot with Visual Studio Code. In order to do it, we hit Editor, Editor Settings, and type here External, so we don't need to look very far. And in Text Editor tab, hit External, and here, firstly, click on, and then you need to type here Executable Path. And this part is pretty hard normally, but I will show you a very cool trick. Alt plus space will show something what is called Flow Launcher, highly recommended program. When you install it and you hit add plus space, okay, again, you can do something like that. Hey, I need to find the path to Visual Studio Code. Okay, this is this program. Now I will hit the right arrow key and I will open target folder. Okay, so this is the place, isn't it? Yeah, so I need to just copy this, open this, hit this, and I am inside code X. Wasn't it cool? Let's close it now. And now, when you hit this, we are connected to Visual Studio Code. But as you can see, we do not have any hints. I'm gonna change the profile to the one that I have for Godot, okay? You don't need to do it if you don't want, but I like to have different profiles for different spaces. And now, when I go here, I need to install Godot tools, okay? So when you install Godot tools, okay, and also I highly recommend Codium, right? Built-in free auto completion, okay? But that's not all. We need to now also open the folder where our project is, okay? So in order to find it, you go here and then you do right click, open file in manager, and then you just copy the path, right? Then you go here, back, paste, and now you open this, right? It's very important that you are in here, select the folder, and you're gonna open, okay, I got it with the default profile, right? So I need to change it back to Godot. And now, as you can see, we are being asked where the Godot executable is. So I need to select Godot executable, and this is the place where you have your Godot installation, right? So in my case, it is in this place, right? I just open it, and as you can see, we need to reload everything. Okay, let's zoom a bit and let's go here. As you can see, now we have entire project here, but it's also connected to this. So now, as you can see, I can open everything here, and it's not like this only works here. So for example, I have somewhere some kill zone. Oh, here is signal. As you can see, double click and we are in the place where the signal is. You might be wondering, do you have documentation here? Yes, F1, and when you type Godot.classes, as you can see when I hit enter, it's not only that you can look for your classes documentation, but let's say I want to find something about CharacterBody. As you can see, now I can read about it, and the cool thing is that you can see which scripts in my game is inheriting it, right? So you can, read about it, all the functions, blah, 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 blah. So documentation is built in. You don't need to jump between Godot editor and this place. So pretty cool, isn't it? And of course, if you want to use different language, like for example, C#, right? So type Godot C# and then you can use it here, right? That's the only lesson. Thank you very much.